Good morning, everyone, or good afternoon, or good night, regardless of where you are. Hello, welcome to the first Data Science Summer School organized by Hertie School Data Science Lab and Data and Methodology Center at the Scripps Cluster of Excellence. I would like to thank our funders, the Scripps and the Stifterverband, for their generous support that let this school happen. And I'm extremely happy to see you all here on Zoom and in the parallel session on YouTube. I would like to note a couple technical and organizational details. In the Zoom meeting, you're all muted and you have your cameras off upon entrance. Please do not unmute yourself and do not turn your cameras off unless you have a question. We really ask you to put the question first in the chat so that the instructor and the TAs can handle the question. But if you really want to speak up, please raise your hand and then we will let you speak whenever there's going to be a right moment. Then you would be able to unmute yourself and turn your camera on. If you're in the YouTube session, you can leave your questions or comments in the live chat, and we will try to handle these questions as well. I should also remind all of you that the Zoom session is being recorded. Thank you very much for following these rules in advance. And we shall begin with the fourth workshop in the summer school series. Today we have data visualization with R, and let me introduce Dr. Richard Traunmüller. He's a professor of political science at the University of Mannheim. His online course on data visualization is part of the regular curriculum of the Mannheim Master Program in Applied Data Science and Measurement of the Mannheim Business School, an international program in survey and data science of University of Maryland, College Park. His book project on data visualization for the social sciences is under the contract with the Cambridge University Press, which is really impressive. Richard, the floor is yours. You can share your screen now, and thank you.
Thank you, Olga. Hi, everybody. Let me share my screen. Okay, so welcome to DataViz. And let's just jump right in, people. So you're all data scientists, or you want to become data scientists. So I thought I'd bring you some data. Okay. And what I want you to do is take a couple of seconds and maybe think about what you see in the data. Yeah, maybe you have to squirt your eyes a bit. You know, there's lots of numbers here, very precise numbers. Right? Basically, it's four data sets. Now I apologize for the dog. Off to a bad start. So did you see anything in the data set? Well, you have to move quickly, right? Because there's more. There's more. There's more. There's more. There's more, there's more. Okay, does anyone have an idea of what you're looking at? Did you see any patterns? Well, obviously that's unfair, right? Because there's too much complexity here. So what we usually would do, so of course we would like to reduce this complexity by using descriptive statistics. So that's what I'm showing you here, right? So this is summarizing those four data sets, data set 1 to 4. And all the data sets have an N of 142 observations. And if we look at the means of the X variables, they all have a mean of 54.3. And all the means of the Y variable, they have a mean of 47. Okay, so what else could we do? Well, we could also look at the standard deviations, right? And then we would see that the spread in all the four data sets is exactly the same. We could look at some correlations, we could look at some regression results, and we would find that the results are exactly the same. Okay, so basically the descriptive statistics, our basic data reduction tool, is not very informative. So let me try something else. How about this? Now, if you look at data set 1, if we visualize it, we see that there's two clusters here, right? Let's look at data set 2. Well, what's this? This is a pattern that shows some serial correlation. Okay, let's look at data set 4. It's a circular pattern, okay, which was not visible before. And now if we look at data set 4, what we see, is a dinosaur. Okay, so the case for data visualization. So why is it important to talk about data viz? Well, first of all, data viz gives data form or shape. And as a result, it allows us to see things that we would be otherwise missing or which would be impossible to see. Okay, and so data viz is incredibly useful for summarizing large and complicated data sets. I mean, those were not actually large data sets, just 140 observations, but as the data size increases, visualization becomes more and more important and useful. What's also great about data viz is that it doesn't rely on assumptions of the data, any distributional assumptions, right? For instance, a spread, a standard deviation, or even a mean makes some assumptions, but data viz just takes the data as it is and gives us a sense of it. And finally, what's great about data viz is that it encourages the interaction between the researcher and the data. Yeah, so we immediately see something which pops up, right? And this encourages us to follow up on it and basically helps us formulate hypotheses. Okay, so what I want to do in this course today is basically to do two things. First of all, I would like to discuss some fundamental principles of data viz. And so that's mainly going to be theory and conceptual work. And then we will spend the second half of today, doing some of the things in R. I will show you how to implement some of those ideas in R. Okay, so I should apologize not only for the dog who went crazy with the doorbell, but also I think you will be kind of disappointed if you came to this course and expected to see very fanciful visualizations, like complicated patterns and bubbles and maybe even interactive visualizations. You will also be disappointed if you came here to learn about infographics, drawing little hamburgers and pie charts, or doing things like a word cloud. Yeah. Instead, what I will try to do is I will try to convince you that most of the time, some of those very basic graphical formats will do the job quite well for you. So we will talk a lot about bar charts, about line charts, about scatter plots. Yeah, and I will give you some sense of why those formats are so powerful, but I will also show you how we can combine those elements into more attractive and maybe more advanced data visualizations. Now you wonder and say, well, why is that the case? And the reason is actually simple. So first of all, you came to this course and thought like, hey, I want to be a data viz rock star. Now you're getting this, right? So I think you may be disappointed, but the important point to take away here is that data viz is actually a methodology, okay? So the critical question we have to ask if we visualize data is how can we turn numbers into something that people can understand for optimal decision making? Okay, so data viz is really a method for making sense of quantitative information, and it's not a drawing tool. So it's not at all about making beautiful pictures. The pictures are really just the means for the overall goal of making sense of data, right? And therefore, data sense is more than just encoding quantitative information in visual objects. So, and basically, if you look at data viz, there's three elements to it. Right? And the important point here is that you start out with a problem that you want to solve with data viz. Yeah? And then you decide, that you have data that will help you solving the problem, answering the questions you have, right? And then visualization is really the means that turns the data into something that you can link back to your problem, right? And therefore, data viz is all three things. It's not just down here, right? But it's really the three things. And I think that's why data viz is such a fun topic, why it's such a, also important topic, and interesting because it brings three very different skills to the table. Yeah, so you need to have some substantive skill on the topics you work in. You need some statistical skills, to know how to handle data. And then basically you need some artistic skills to turn data into beautiful visualizations. Yeah, and now if we think about what are some of the problems that we would address with data viz, basically we can distinguish two main classes of problems, right? The first class of problems is exploration, right? So this is basically visual analysis. So here the idea or the goal of DataVis is to get an understanding of what is in the data, what's in the data set, to get a sense of the size and complexity of the data set, and then really explore the data and interact with the data. And again, visualization is just a tool that allows us to make sense of the data. And the second goal is, once we have found interesting things in the data set, then we want to communicate it, then we want to present it to others, right? And that's the second major goal. Yeah, here it's all about communicating the content of the data, to tell a story with the data, and maybe to attract attention and draw interest to what you found. Yeah, and clearly those different goals require different things from the data, maybe, but they definitely require different things from the visualization. And I think that's the first thing to take away here, is that if we do visualization, the first thing to understand or to ask yourself is, what do I actually want to achieve? And then everything else follows from this underlying goal. So let me demonstrate this to you with some examples. So here, that's a classical visualization. It's the Nightingale Rose. And I think some of you may already know this visualization, right? And basically what this shows the causes of mortality of soldiers during the Crimean War. Yeah, it's a classical visualization. You may know Florence Nightingale, a very famous nurse and statistician, right? And basically she got numbers of the causes of death, and that's how she visualized them. And the way this works is that each segment is a month, right? And then the size of the segments are the numbers of dead soldiers, and then the numbers of dead soldiers are classified according to the cause of death, right? And then we have red, which is death by wound, right? We have black, and that's something I have to look up. That's, I think, every other cause of death. And then basically the blue, which is death due to zoonotic diseases, so basically infections, right? And I don't know, can I ask in the chat, do you have a sense of what the goal was of this visualization? So is that a way to explore data? Is it a way to present data, to convince people of something? Can I see the chat? I don't see the chat. Maybe you're not asking questions, that's fine. Yeah, I think here the goal, oh, here's the chat. Here's the chat, okay. Yes, Johanna says to communicate information, absolutely, yeah. So basically this visualization was actually drawn to convince policymakers to change the health and sanitary conditions at the army, right? So the pure goal here was, so Nightingale already knew the problem, right? But now her goal was to communicate it in such a way to convince policymakers. Yeah. So Dimitra says, yes, but the way of visualization can also be very misleading. Why can it be misleading? Dimitra, why can it be misleading? Well, for one, what's a bit tricky here is that actually the quantity is encoded along the length here, right? But what happens is the length actually lets the area of the plot explode, right? And this kind of exaggerates the number. Yeah, and that's what Dimitra just says here in the slot. The graphics can show high numbers that aren't that high, right? So that's correct. Yeah, this would be one problem. Let me show you another graph of the same data. Yeah, so here we have a line graph. Okay, again, we have the time, the month, right? And then we have the percentage of soldiers that died by cause of death. And again, Here they changed the color code a bit, right? Reds are wounds and injuries. All other causes are now orange, but the preventable, the zoonotic diseases are in blue, right? And then we see the clear spike here that most of the deaths really are due to preventable diseases, right? Due to infections. Now the question is that a fanciful plot? No, it's just a line chart, right? What do you think? Which one would be more eye-catching? Probably the first. Which one would be more convincing if you want to show it to policymakers? Maybe the line chart. It's maybe easier to understand, right? So it gets the message across much, much easier, much more effective. And this could also be a graph to learn much more about the data. For instance, here's a little detail here. And once we look at this data, at this additional plot here, we actually see that most of the time during the war, the preventable diseases were the major cause, except for one period where actually wounds and injuries were the most frequent cause of death. And that's basically something we maybe would have missed in the other graph. Okay, let's not spend too much here. I think the important takeaway for now is that we have to distinguish two types of visualizations, the exploratory visualization and the explanatory visualization. So one is to make sense of data and the other one is to present it. Yeah. So the goal of exploration is to really notice something, force ourselves to notice something we had not expected to see in the data, right? Whereas the explanatory visualization, the presentation really happens after the fact. So we want to force the readers, our audience, to really see the message that we want them to see. Yeah. And therefore, the first kind of visualization is really for ourselves, right? To first make sense of the data, whereas the second part of the visualization, that's really for others. That's where we put it out in the world. And because of that, basically, there's different requirements for the graphs. Yeah. For exploration, really what we want to do, we want to get lots of insight very quickly. We don't have to care about the look of the visualizations. You know, they can be quick and dirty. They don't have to be very attractive, right? Just make sure you produce lots of them to get a good sense of the data, right? And then finally, once you want to communicate, then probably what you want to do is not to show too much. Yeah, maybe restrict yourself to a very few visualizations, carefully craft them, and really tinker and tweak them and make sure that they look attractive. Okay, so regardless of what your goal is, there are some principles that will basically improve your data visualization skills. And those fundamental principles of analytical design, that those are not principles that I made up, but those are actually design principles by Edward Tufte. And you may have heard the name Edward Tufte. Yeah, he's basically the guru of modern data visualization, right? And what's interesting about those principles is that they basically link back to our triangle. Yeah, so the basic idea or the intuition is the following. If we want to use data viz to make sense of quantitative data and to help our analytical thinking, then what the data visualization should do, it should really support our visual thinking by basically closely following the principles or the basic processes of what it means to do analytical thinking. Yeah. So what's the basic analytical process that we do? Well, we compare, we contrast, right? We contrast before, after. We look at differences between groups. Yeah, so that's the most basic analytical procedure that we do. And therefore, if a database is supposed to help us to analyze data, then it should focus on comparisons. It should focus on contrasts, and it should focus on differences, right? So, and if you think about how you think analytically, right? What happens once you have found differences? Well, the next step, of course, is to inquire, where do those differences come from? Why are there differences, right? And therefore, we are looking for causality, for explanation, for some systematic structure behind those differences. if data viz is supposed to support us in that regard, then it should also help us, see the explanation. So we should show the explanations, show some systematic structure. And then the question is, how do we usually do this? Well, we do this by bringing in additional variables, right? So if we find differences in earnings, for instance, between groups, then the question is, well, what explains the differences in earnings? And usually we'll bring in other variables, like your skills, your experience on the job, et cetera, et cetera. And therefore, in an analytic design, most of the time we will use multivariate data. That is, we will use more than just one or two variables in the visualization, right? Yeah. Okay, and this basically goes for exploration or presentation of your visualizations. Yeah. So, and the other three principles, they are more important for the presentation than they are for the exploration, right? Remember, if you're exploring data, it's really you know the variables, you don't need much description, but as soon as you present your visualization to other people, it's important to completely integrate words, numbers, images, and diagrams. Yeah, so a data visualization doesn't stand on its own, right? Yeah, you can point out interesting things in the visualization. Yeah, you have to thoroughly describe the evidence. You need to attach a title. You have to make labels. Yeah, maybe name the source, what's in there, right? And then finally, the last principle, and that's a really important one, and this also links back to the little triangle with the problem on top, is that ultimately, if you want to make a good visualization, make sure that you use data that's, first of all, good data, high quality data, and make sure that the content is relevant. Yeah. So ultimately, yeah, you can produce beautiful images, but if nobody cares about the problem you're trying to solve, then by definition, you don't have a good data visualization. Okay, I know this is kind of abstract. Okay, so let me show you one example, which, according to Tufte, the guru of modern data visualization, makes a perfect job in fulfilling and ticking off all of those principles. Okay, so this is according to Tufte, the best graph ever produced. Okay, so I hope you're very excited about the best graph ever produced, and I will show it to you now. And I know what you're feeling, a bit disappointment. What? A carrot? What is it? Right? And this is supposed to be the best graph ever drawn. Some of you may know this graph. Yeah, basically, this is the army, the French army, that Napoleon led to Moscow. Okay, so again, it's historical data. Again, it's data about war. Okay, and now let's try to understand how those principles actually apply to this graph. So what was the first principle? Well, we should focus on comparisons, on differences, okay? So, and what this graph actually is, that's a flow map. So it's basically showing a quantity as it's going through space. So underlying this lines here is a map of Russia, okay? And then it's showing over time, yeah, the movement of the quantity. And what the quantity is the size of the army, right? And as we see, as I tell you, the brownish color, that's the way to Moscow, okay? And then the black is the way back. And then the question, what's the crucial comparison here? So why is this a good visualization? I think the biggest contrast is actually right here, right? So the width, this gives us the size of the army, right? And what this visualization basically contrasts is, hey, look how many soldiers went to Moscow, right? And how many came back. The short answer is that was a disaster, a military disaster. Yeah, and that's already the main message of this visualization. Okay. So the next question, of course, is how can we explain this? What's the reason behind this? And the way to do this or to suggest an explanation is actually to bring in more data. Yeah. And if you look very closely here, this visualization here is a line chart underneath it, which basically shows the temperature on the way back. Okay. And this seems to suggest that the author of the visualization tries to give the explanation that why so many soldiers died was because of the cold temperature. Okay. And I don't know whether you know the story, whether you know anything about history. Yeah, apparently what happened is, or apparently how the military works is so you can't carry all your resources with you. So you basically, on the way, you depend on looting and stealing stuff, right? And then basically what happened once the French army hit Moscow, they actually found Moscow burned down to the ground, right? So they could not, they could not fill their resources. Basically, they had to return. Right, so that's maybe the underlying, another underlying explanation, which is not necessarily shown in the plot. Yeah, here this plot suggests that maybe it's temperature. Okay, so and then the question is, okay, how many variables are in there? Okay, so we have the size of the army, we have to Moscow, back to Moscow, we have temperature, we also have space, right? 2 coordinates. That's already a multivariate visualization. So the third criteria is fulfilled. And then the fourth rule would be, well, completely integrate your data viz with numbers and with text. Yeah, and that's basically done here as well. So we have the little numbers here. So we have the visualization, we have the exact numbers here, which show how many soldiers are there, right? We have a scale here. We have descriptions, right? We have names of places, right? So it's all integrated. Then the fifth principle, is to thoroughly describe the visualization, and that's very well done here, right? So this is in French, but basically it describes very well what the data are, where they came from, what we're supposed to see, who the author is when it was constructed. Yeah. And now finally, the last principle, is that important? Is it important to learn about why people die or why wars are bad? I think it is. Yeah, and it does a very good job at that. Usually, and this is something that doesn't work so well here in our not so interactive format here, is the ultimate test for you to understand whether you got a great visualization is really to observe your audience, how they engage with your visualization. And the ultimate test is if people start talking about the content of what you're showing, then that's a good sign, right? If instead they're talking about, little design features and, oh, did you do this with ggplot too? Then you realize that maybe what you're trying to show is not important enough. Yeah, the people are actually willing to engage with the content of your visualization. Okay. Let's pause here quickly and maybe take a couple of questions in the chat. Any questions in the chat? No? Okay. That's fine, and we can go on. Okay, we ask, yes. Oh, from YouTube. Yes, well, yes and no. We will also use other packages. So the question was, will we usually mainly use base R for the workshop? Yes, but let's save those questions for the second half. So let's talk a bit about graphical perception, okay? So now we first talked about some very fundamental principles, and let's now talk about graphical perception. So what is graphical perception? So if we construct a graph, what we're basically doing is we're encoding information. So we're turning numbers into physical objects, right? So those would be, turning numbers, aligning them on some position in space, giving it shape and size and color, right? Then if an observer looks at the visualization, what's happening is that this visualized information is decoded, by the visual system. Yeah, and the important point really here is how people understand your graphs. Okay, so, and if we understand how this works, what we can do is we can translate this knowledge into rules for how we should construct our visualizations, right? And if we follow those rules, what will happen? We will construct visualizations in such a way that important informative patterns stand out. And if you break the rules, then what will probably happen is that we come up with a product that's incomprehensible, or even misleading. So it's important to understand a bit how this perception works. And here, this is probably the briefest summary of how this works. And disclaimer, right? I'm not a psychologist, so if there's any psychologists, they will probably know this much better. Yeah, but I think there's a couple of important things to understand with perception. The first is that perception is really something that happens in the brain, right? Clearly, we have visual stimuli, light that hits the eye, right? The pupil goes to the retina behind, and this is translated into neural signals, right? But really, the perception is happening in the brain, right? And again, I'm not a psychologist, so this is very simplified. But to think about the brain here means that we should really understand that there's three distinct pieces or parts in the brain that are important for perception. First, the iconic memory, right, which is also called the visual sensory register, and then the short-term or working memory and the long-term memory, right? In each memory, different things happen, right? And the human brain has different talents and weaknesses in those areas. Yeah. So what happens, first of all, if the visual stimuli gets translated into a neural signal, it will first enter the iconic memory, right? And what's happening here is pre-attentive processing. What this means is now the perception, the process is unconscious, it's automatic, it's effortless, right? And what it's all about is seeing visual attributes, right? Perceiving visual attributes such as color, shape, motion, right? And that's where we are really good at, right? So the human brain is really good at here, right? But then once we see the visual objects, the attributes, what we do is we reason about them. And then we switch to the short-term working memory, right? And here the attentive processing happens. And that's basically where we process pieces or chunks of information, right? And that's where the human brain is really not so good, right? So, I mean, how many pieces of information can we hold in our working memory at the same time, right? Previously, there was the magic number of 7 ± 2. Yeah, so you can hold in your memory 7 objects. I personally find this to be on the high end. Yeah, personally, maybe it's more 4 objects. Yeah, so, and now for data viz to be effective, we need to capitalize on this talent here. Yeah, that we're really good in seeing visual attributes, and we have to help our audience with their limits in working memory. Yeah, I should also say that long-term memory also plays a role. Yeah, because we can learn stuff. And in long-term memory, there we store familiar patterns that we know certain things should show up in a graph. Here it's also stored cultural ideas about meanings of color, for instance. And what's also stored here is our familiarity and expertise with certain visualizations. Yeah. Okay, so let me demonstrate this to you. Here, there's a row of numbers, and I would like you to pick up how many 3s are there. And then, and that's kind of hard to do, right? Because you probably, what you will do, you will scan the rows and you will count, okay, 1, 2, 3, 4, 5, 6, maybe it's 6, right? So what if we capitalize on our pre-attentive processing? How many 3s are there? Now it's immediately visible. It's 6, right? So this pops out immediately, effortlessly. We don't have to work hard for that, okay? And there are several such pre-attentive attributes. Yeah? What we just saw is color, which is one of the most powerful, along with motion, right? but there's others like length, right? The orientation, the size. Those are all the things that we see immediately. Position along 2D, right? So that's something we can use and where we're really good at noticing. Okay. So, and now that we have those pre-attentive attributes, we can use them to do two things. First of all, understanding how they work can guide our choice of graphical formats. So we can choose how to encode quantities into visual objects. And we can also use it to guide our design choices. Yeah, so we can create visual hierarchies, make some things pop out, push other things in the background, right? And we can do this purposefully if we know how those attributes work. Okay, and now let me show you maybe 3 examples of how this would play out in DataVis. Okay, so again here, what's here? So we have a couple of dots, pre-attentive processing. So there's bright pink colors, they pop out immediately. There's no way for you, even with hard training, to not see those bright pink dots, right? They just stand out. So, but what's important to understand is that the pre-attentive attributes, the way we see them is by means of contrast, right? Because we see them because they're very different from their surrounding. So one thing is that if everything pops out, nothing pops out, right? So if you compare this to this, here it's very easy to see the 4 bright pink dots. But if we make everything bright, right, then what will happen is it will be much harder to see the pink dots, right? Those green, the light green is really something that's also screaming for our attention, or the bright red, it's really screaming for our attention. Yeah. So the important point is it's about the contrast, right? It's not just about being bright and popping out. It's really about the contrast. Now, how does this apply to some of the visualizations that we see in the real life? Oftentimes, what you will see in real life is that people will use bar charts and they will color every bar, right? So I'm pretty sure you saw bar charts like this. Yeah. I mean, I have to say this bar chart here actually looks quite nice. Like it's a rainbow. It's very tasteful, but you know, it's not like every bar is screaming for your attention, right? And in a way, that's a waste of time. Not a waste of time, a waste of resources, right? Because you could have used the pre-attentive attribute of color in a much more targeted way. For instance, by just highlighting the one bar that you really care about. Yeah. Okay, another example. Look at the 2 circles here and try to understand how much bigger is the second circle. How much bigger is it than this one? Is it double? No, it's probably more than that. Is it 5 times? Maybe it's 10 times. Yeah. So what's interesting here is that, first of all, you immediately realize this is larger than this, right? So you don't have to work hard for that. Yeah, that's basically effortless. But it's very hard to pinpoint an exact quantity, an exact ratio between the 2, right? And this tells us also something about our pre-attentive processing capabilities. So we're not very good in judging areas, right? And what does this mean for DataVis? You will see lots of pop visualizations that use bubbles because people like bubbles, you know, and then they would like to compare sizes, you know, I don't know, population size with bubbles, right? But that's not very efficient. I mean, here's an example. That's German data here, turnout versus population density. And that's, I think this is, what is it, counties, German counties. And here I use bubbles to make them proportional to population size, okay? So does this work? It probably does in this context, yeah? Because here the idea is not so much to actually make an accurate comparison in size, it's just to give us a rough sense of, you know, what are the large bubbles. So this is Berlin here, the Berlin bubble, right? I don't know what that bubble is in this tiny one, right? But it gives us a rough sense, right? But, you know, what it doesn't allow us to do is to make exact judgments. Okay, so usually there's a very, the use of bubbles is very restricted. Okay, another example. Look at the 5 colors and please order them in in increasing order. Order them from small to large. So how would you go about it? Would you like black? Well, maybe you should start with yellow. What's after yellow? Maybe green, and then it's kind of hard, right? The point is that you cannot order color, right? Or color hue, I should be more exact here. Yeah, there's no natural ordering in these colors. And now let me show you an example. Even though you will sometimes find visualizations like this one, for instance, on maps, would actually use color hue as with a quantitative scale, right? On maps, you would say, well, red maybe is high up in the mountains and blue is very low down in the sea, right? So can you get away with this? It seems like a scale, right? So Renato says it depends on the context. Yeah. What would be the context where you could get away with it on maps? Yeah, so red and blue works great on climate change, right? And why does it work great? Because what we do is we associate red with something, with temperature, right? So red is hot and blue is cool, right? So we have an intuitive feel for it, right? But now, Renato, let me ask you, is how much higher is green to blue? Is it 2 times as high as blue? Or is it 3 times as high as blue? And how much higher is orange to green? Is it like 3 times as large? Is it maybe 10 times higher? It's incredibly hard to tell, right? Or let's say it's impossible to tell, to be honest, right? So even if you have a scale, I mean, you could put numbers here, right? But then basically what you're doing, you're looking at the numbers, you're linking the number to the color, and then you're doing the math with the numbers, right? Which is not very efficient if you're in the business of database. So some people would argue, well, okay, color hue doesn't work, but can we use gradients, right? Can we use gradients? Yeah. And again, here, let me ask you something. How much large, or what fraction of red, of bright red, is purple? Is it half? Is it half of red, of bright red? Is it a third? It's impossible to tell. Yeah, you cannot make a quantitative judgment. But let me contrast this immediately with something else. So let's take purple here. Do you see this bar here? This bar extends to 7, okay? Do you see this bar? What fraction is this bar from this bar, the largest red bar? Can you make a judgment call here? Is it half? No, it's lower than half. Is it a third? Yes, it's pretty much a third. So this is around 7 and this is 21. It's pretty much a third, right? Do you see it? Right? So length is perfect. For length, it's easy. Color, it's basically impossible. Okay, so I think you got the point, people. So let me just summarize it. Not all visual attributes are created equal. Yeah, so we cannot use every visual attribute, although we're good at seeing them, right? And it's, yeah, we don't judge them quantitatively. And basically, there's only 2 attributes that we are really accurate in perceiving quantitatively. One is position in 2D, right? So where are you along a scale? And the second one is length, as we just saw, right? And then there's some things that there's no way we can perceive them quantitatively. We just saw color hue, just doesn't work. Enclosure, shape, is a star, how much more is a star than a square? And how much more is a square than a triangle? It doesn't make any sense, right? Orientation also, right? And then there's some features that have limited quantitative, we can perceive them limited. Yeah. So for instance, as we saw the bubble, right, we could kind of say, well, the bubble is larger, much larger, but we're not very accurate, right? And the same goes for color intensity and the width. Yeah. Okay, so Hui says there are some participants that are colorblind. If possible, it would be great if you could describe some of the colors in the chart for new slides. Thank you. That's an important point, right? Most of the charts that I will show later do not use color schemes that are problematic for colorblind people. Yeah, but that's of course a consideration. And we can come back to this issue. Okay, so now that we talked about this, I think you may understand why in the beginning I said, you know, maybe we should focus not on word clouds and hamburgers and bubbles, right? But maybe we should focus on scatter plots or dot plots, line charts, and bar charts. Because if you look at those formats, what they really are, right? What's a dot chart or a scatter plot? Well, the visual objects, right? They're in 2D position, right? Along X and along Y. And we can judge this very accurately. Yeah. What's a line chart? It's also 2D position along X and Y, only that it's connecting observations to give shape to values. Okay, and therefore we can see trends. Yeah. And then finally, what's a bar chart? Well, a bar chart also uses position in 2D and the length of the bar. Yeah. And we know that these attributes are something that we are very good at perceiving. And that's also the reason why we see those graphical formats, right? Because they work. Okay. And now I don't know how many of you are political scientists. I would guess some of you are. So that's actually something Felix and I did. So Felix, our TA, and I, what we did, we looked at all HAPS. So that's the American Journal of Political Science. So we looked at all issues between 2003 and 2018, and we classified all the visualizations that were used in the discipline, right? And this is basically showing the shares or the percentages of different formats. And what's interesting here is, and again, just reinforce the point, like a third of all graphs that you see in political science, right, are line graphs, right? Another third. So if you connect dot plots and scatter plots, right, that's another third, right? Right, and then bar chart comes next, and everything else, you know, is used much less. Although even here, those are things that are very common. Maps are common, density plots, histograms, box plots. Yeah. Just to give you a sense. Yeah. So if you're thinking like, oh, maybe I should do more like fanciful bubbles and visualizations, maybe they won't work. Right, and maybe that's not what your audience expects. And my guess is that this will look very similar in economics, in sociology, and even in psychology. Yeah. So we have a question on YouTube. By quantitatively perceived, presuming the variables being continuous, such that it leads to the problem whether red is more than blue. That's an excellent question, right? If we just care about, so that's a great question, right? Quantitatively perceived really refers to continuous variables, right? Of course, if you care about categories like the party from CDU, SPD, Greens, etc., then of course you can and should use, for instance, color hue, right? Right? Or you could use shape. Yeah. Those things will be categorically perceived. Yeah. So that's a great point here. Okay, so how are we doing on time? We're still good. Okay. Do we have time for this? I think we do. So now that we said, well, you know, those are favorite candidates, let's maybe compare those different formats and see what are some of the comparative advantages. So what you see here on the left is a bar chart, and this is data. So let me make sure that this is correct, what I'm telling you. Have you heard about the Google flu searches paper? So apparently there was this paper where you can predict the outbreak of a flu by Google searches. So basically, if people Google a lot for medicine, flu, or tissues, right? So this search behavior can actually predict the flu outbreak. Right. And what this paper basically did is try to understand whether Google searches would also predict the sales of media items, of movies, games, and music, right? And basically, so that's the flu, right? And those are the different media items, right? And here the quantity is basically prediction. Maybe it's a correlation, how strongly the search behavior correlates with the actual purchasing behavior later on, right? And we see 3 different models, just the search, right? Then some baseline model, which would be your average marketing model, and then a model that combines 2 information, the 2 methods, right? So let's take a look. Is there anything that pops out immediately that we can see? Well, first of all, we see that, well, what do we see? I see 2 things. You can type more stuff in the chat, but I see, first of all, well, the search really worked well for the flu and not so much for the media purchasing. Maybe for movies, but much less for games, video games, and even less for music. Okay, so that's already something we pick up. And another thing that we see is that basically combining traditional methods with the search method, right? They're always the best, basically, or at least as good as search. Yeah, that's something we can pick up. Yeah. So now let's translate this into a dot plot. Okay, and for those of you who don't know a dot plot is basically just a dot along a scale, right? So it's showing the quantity along a scale. And what's a bit weird here is, oops, what's happening here? Wait. Okay. What's happening here is that now the games are basically divided into 2 groups, non-sequels and sequels, but that shouldn't worry us too much. Yeah. And then the question is, now with the dot plot, is that easier to see the patterns? I mean, does anyone want to comment in the chat? Well, it's kind of hard. I mean, of course, we're not using color, which really helps here, right? But basically what we again see is that search doesn't work well for music, right? It works well for flu, and well, not so great, right? So that's what we picked out. And then do we also see that the combined always is best? Yeah, kind of. Yeah, so it's not, yeah, the question really here is that an improvement over the bar chart? And why I'm asking this question is because many people will have learned from Cleveland, right? Very distinguished statisticians, that dot plots are actually superior to bar charts. I don't see it so much here. However, there's one problem with the bar chart here. And can you pick up the problem with the bar chart? If you look at it very closely. Does anyone see it? What the problem is? And maybe to see the problem, think back about how we encode information. So how does a dot plot encode information, and how does a bar chart encode information? So I just said the dot plot just puts a dot along a scale, so that's just 2D position, right? So the number is translated into a position along a scale. What does a bar chart do? Well, it translates a number into the length of the bar, right? And do you see a problem with the length of the bar? The problem is that the bars do not start at 0, okay? So they start at 0.4. And basically what this means, so if you have different bars and you don't start at 0, you just chop them off, what will happen is you're basically distorting. Yeah, then the length does not correspond to the underlying quantity anymore, right? Yeah. So, and that's something that's bad in a bar chart, because by definition, the length of the bar should give us the quantity, but it's basically no problem for a dot plot, right? The dot plot doesn't have to start at 0. Why? Because it's just a position, right? The dot here, right, that's not distorted by chopping up or starting not at 0, right? And the difference between, or the distance between these two dots, they just are what they are along the scale. Yeah. However, if you do the same with the bar chart, right? So if you compare this bar length to this, and you start at 0, you see there's just a tiny difference here. But if you chop it up, you don't start it at 0, then you would think that, hey, this bar is only half this bar, which is a distortion, right? So the point here is that maybe one comparative advantage for the dot plot is that it's easier. Let me go back. It's easier to show small differences because you can zoom in, right? You don't have to start at 0, right? Whereas for a bar chart, you have to start at 0, and then maybe small differences are not as visible. Yeah, and the important point is zooming in is not cheating, right? What is cheating is not starting your bar at 0. Okay, let me show you something else. We could also use a line chart. And I think many of you will find this offensive or controversial, right? Because I assume that many of you think that we should only use lines for trends, maybe continuous data, and not for categorical comparisons, right? But what's happening here is basically, if you try to make sense of a bar chart, what you're doing is you're comparing the tips of the bars, right? So you're looking at this bar, look at the tip to see the height, and then to compare it across categories, what you do, you connect this color to this. So that's a dark gray to a dark gray to this to this. So that's what you're doing with your eye, right? And then you see, okay, well, the combined method works well for the flu, not so much for music, but quite well for music, for movies, okay? And then if you look at, I think the light gray, that was the search behavior, works excellent for the view, not at all well for the music, yeah, but for the games, okay, and much better for the movie. Yeah? So basically what you're doing, your eye is moving and making these comparisons. And that's basically what this line chart does directly. Yeah? And then the question is that more efficient than not? So what do we see immediately here? Some of the patterns we already saw before, right? But much quicker. So the first thing that stands out is that the combined line up here always is best across all categories, or at least as good as search, right? And we also see immediately that here, yeah, the search doesn't work well for music. Yeah, so that's really easy to pick up. Yeah, because basically what you're visualizing here is the actual comparison that your eye makes. Yeah, but it makes it easier for you. Yeah. So maybe should we use a line chart? I would suggest we could use it. I know some people think that's not a good use because we're basically what we're doing by connecting those dots. There's basically a line between the categories where no data is. Yeah. Well, but at least it's reinforcing our comparison. Another thing is, does a line chart have to start at 0? This one starts at 0. Does a line chart have to start at 0? What do you think? Anyone in the chat? I mean, that's a discussion I see it very often, and it's very easy to answer. The answer is no, right? It doesn't have to start at 0. So we could cut off the graph here at 4. This would not distort anything. If anything, it would zoom in and make the differences larger, but not distorting them, just making them more visible, right? And what's the reason? Well, the reason is that the line chart also uses position along 2D, to encode the information and not length. Okay. Okay. Any questions to this? Any questions in the chat, in the YouTube? No, okay, then let's go on. Then, so far we discussed graphical choice of graphical formats, okay? And the way we chose them were based on our knowledge of pre-attentive attributes, what we can see well, what we can perceive quantitatively, what not, what we're allowed to do, right, with different formats. Let's now turn to design questions, okay? Let's talk about the Zen of visualization design. Yeah, there seems to be a consensus in the database community, or kind of a consensus, that more stripped down, more minimalist designs are preferable. Okay, and ultimately, this also links back to the fundamental goal of what you want to do with a visualization, right? Is you want to convey information. So basically, what you want to do is you want to focus only on the thing that's necessary, right? You don't want to overload your visualization with complexity that's distracting, etc. You just focus on the important thing. And therefore, like a Zen design maybe is a natural way to go, right? So how do you arrive at a Zen design? Again, those are principles that I stole from Edward Tufte, yeah, who's one proponent of this design. And there's a couple of principles and also maybe tricks of how to arrive at such a design. The first principle is to, above all else, show the data, right? And that makes sense. Look, if you have a problem, you want to communicate the data, you want to understand the data. So clearly you would like to focus on the data and not stuff that's unrelated to the data. Then what you should do, you should maximize the data-ink ratio. Now the question is, what's the data-ink ratio? Let me show this data-ink ratio. That's a concept by Edward Tufte, right? And basically what it is, it's the amount of ink that you use, right? So if you're drawing a visualization by hand with a pen, it's the amount of ink that you use to draw data points, right? Over the total ink that you spend on printing the graph or drawing the graph, right? So, and basically what this means is that this is the proportion of ink that's devoted to the non-redundant display of information, right? So as long as you show, well, the data is the thing that you want to show, right? And the part that you spend on showing the data, that's clearly non-redundant, right? And at the same time, that's 1 minus the proportion of things that you can erase from your graph without any loss in the data information. I know this sounds a bit abstract, but I think it will become clear in a couple of seconds. Okay, so let's first go back. Yeah, so what we should do is we should maximize the data-ink ratio. Yeah, make sure we use most of the data, most of the ink to actually show data and not other stuff. And we do this in 2 steps. First, let's erase non-data ink, right? Whenever we use color, like ink or pixels or whatever that are not related to data, maybe we can get rid of those, right? And then this would already be quite good, but then we can strip it down even further by erasing redundant data ink, right? So not every ink that we use to show data is equally important. And then the point is that this is a process that you can revise and edit. You can cycle through it. Okay, so I understand that this is kind of an abstract, but let me show you an example. And I have to say a very radical example by Tufte himself. Okay. What we see here is a bar chart, or groups of bar charts. So those could be experimental conditions, right? So I think we have different variables here in the upper, middle, and lower panel. We have different groups and whatever the grouping, right? And now the question is, well, what is data ink and what is non-data ink? So what is used that's actually not not showing data. And once we have identified, then we could get rid of it. Do you have any ideas? So those are bar charts. So the bars probably show data. Not probably, they definitely show data, but what's not data? Any ideas in the chat on YouTube? Well, how about those lines here, right? Those are not showing data. How about the stars? What are they showing? They're showing significant differences, not data. What else? Here, those axes, are they showing data? Not really. So let me show you what Tufte identified as not being data. Quite a lot, right? So the lines around the plots and actually the scales, right, are not data. The stars, that the ones I picked up. And then the question is, well, what's left? This is what's left, right? And that's basically just showing the data. So we have length, right? That's showing the data. We have the confidence intervals to show the uncertainty. We have some numbers for the scale, yeah. And then we have like a little line to group, yeah. And we need the labels, of course, to make. So that's what Tufte would suggest to do, right? I realize that's an extreme example. So let's be a bit more, maybe a bit more helpful for our purposes. And here, those are Stephen View's. Stephen View is another data viz expert, and he basically translated those principles into things that we may better understand. And first of all, he's already in a computer age, so he talks about pixels and not ink, right? So it's all about putting pixels on screen to visualize data. And he says, well, what we should do is we should reduce the non-data pixels as before, right? And what we should do is we should enhance the data pixels. Yeah, so make sure you reduce what's not data and make sure you enhance what is data, right? And how do you reduce non-data pixels? There's two steps here, okay? First of all, just subtract any unnecessary non-data pixels, okay? So ask yourself, would the data suffer any loss of meaning or impact if this were eliminated, right? It's just you can test this for yourself. If you answer like, no, actually, no, I wouldn't lose anything, well, then get rid of it, right? And then the remaining non-data pixel, you can de-emphasize and regularize them. Yeah, and basically what this means is you want to push them into the background. Yeah, so what you want to do now, you want to create a visual hierarchy. Some of the elements should be in the background, other elements should be in the foreground, right? The important stuff should be in the foreground, it should pop up, right? The auxiliary things that are important should be there, don't get rid of them, but they should be somewhat put in the background. And here, of course, what we can do is we can use our knowledge of the pre-attentive attributes to make those judgment calls and to create the visual hierarchy, right? So what stands out, what pops up? Well, large things stand out, thick things stand out, colorful things stand out, right? So, and what goes into the background? Small things, thin things, light gray, right? Those are all attributes that make things fade into the background. So in order to de-emphasize and regularize non-data pixels, that's what we should use. Use thin lines, light gray for supporting non-data components. Yeah, so use this for your axes, your labels, everything that's not data. You can use use this design. And I will show this to you in a second, right? So once you have done this, enhance your data pixels. And there's two steps also. How do you enhance the things that you really want to show? Well, first of all, you subtract the unnecessary data pixels. So not all information is equally important, just focus on the important piece of information. And then what you do, you emphasize the most important data pixels. And again, we know how to emphasize it, using attributes of pre-attentive processing. So make it colorful, increase the size, make it thick, right? And now let me show it to you. Yeah, so that's maybe a bit better example. So those are several designs of a scatter plot. Okay, so here, That's it's not very, I think everybody would agree it's not very attractive, right? So we have a gray background, we have a grid line with dash that's causing lots of noise here. And basically that's not showing data, right? And the question is, what if we got rid of all the pixels in light gray? Would our plot suffer? Probably not, so let's get rid of it. Would our plot suffer if we got rid of the grid lines? Probably not. So let's move to this, right? And if you compare these two things, I mean, let me know in the chats what your feeling is, right? I think this is a better design, right? Why? Because it makes the data stand out more. And how do we achieve this? Basically by getting rid of redundant non-data pixels. Yeah. Also, little footnotes for the people in the YouTube and in the Zoom who are thinking about, hey, I really want to do ggplot, right? Initially, ggplot had this kind of a design with the light gray background. Yeah. Just saying, right? Which is maybe not an optimal design. Okay, so now let's move from here to here. So maybe we can enhance the data by just making it bigger. That's not so good, right? I mean, that's basically hiding some of the patterns here. So maybe I should erase some of the redundant data pixels. Some of the pixels here are showing data, but I don't really need them. And in fact, they're obscuring patterns. So I'm making them a bit transparent, making them smaller, yet just taking away some of the pixels. And then what we see, the pattern actually stands out much better, right? So now we can revise and re-edit. So are there still some elements that are not data, that are redundant? Well, how about this here? Do we really need the box? Maybe we can just get away with an L. Yeah, no loss. Then let's go further. Do we need those large ticks? No, we don't. Let's get rid of them. Actually, do we need this axis? No. Right? Actually, this works just as well. All right, this already looks quite clean, right? Quite zen. So let's try something else. Maybe let's go back to the L-shaped, but let's put it in the background by making it light gray. Do you see? Do you see the hierarchy here? So right here, everything is in black. So actually here, it's on the same plane, right? So the auxiliary components, they just stand out as much as the data. Yeah, but once we turn them into light gray, what happens? They are pushed into the background, right? And the data stands out. And then finally, if you really want something to pop out, you just make it colorful, pink, right? And here I have to say that's maybe not the perfect example. It would have been a better example if just part of it. So here, every data point pops out, right? And maybe that's a waste of our abilities, right? Or our menu. Because what we could do, we could just focus on things, on subsets of the data that we really want to pop out and focus on. Yeah, so we could use like a pink dot to show an outlier or to show a certain region, right? And then what we would have is we basically would have a 3-layered hierarchy, right? Background, data, and then the most important data. Does that make sense? Let me know in the chats. Let me know on YouTube.
Richard, we also have some questions from earlier about the truncation of the y-axis.
Okay, what was the question?
For once, would it be misleading to leave out or to truncate the y-axis for line charts?
No, that's what, well, it depends on what you mean by truncating. So if you mean by truncating not starting at 0, that's not a problem, right? Why? Because the line chart is not using length to encode the quantity. It's using position, right? And as long as the position is correct, it doesn't need the 0, right? It's something else if you use an area chart where you color the area beneath the line. So you have a line chart that shows time or some quantity over time, and then you color the area beneath the line. Then what's happening is that this area is basically encoding quantity by the length or the distance from the x-axis to the line, and then it would be misleading to not start at 0, right? And yet another problem is where you don't truncate by not starting at 0, but where you truncate it in the middle. So sometimes you will see like a scale here, and then there's a little dash between, like a cut, and it would start somewhere else. And this is clearly misleading, right? Because you're fiddling with the scale. Yeah. Does that answer the question?
I think so. We also had the question if there are good ways to show the truncation. I think this refers to what you just mentioned about cutting in the axis.
Yes, but that's something I don't recommend. What's definitely a good practice, people, is, and this actually goes back to the principles of analytic design, is a thorough description of what the plot is and what it's showing. So it's a very good practice to have a caption beneath the plot that's explaining what's in there. And then, it's very good practice to just write in there, hey, note the y-axis does not start at 0, right? So then you're being very, very open about it. Yeah. Other questions, Felix?
Yeah, the last question was, when you display low frequency behavior, for example, around 0, would it be a problem to cut the axis, or should it also contain the value of 1? So have a whole axis from 0 to 1 when there's just low frequency behavior around 0, or can we cut the axis then?
Well, of course you can cut the axis then, right? I mean, look, to put a bit more nuance to this question, again, it depends a bit on what you want to do, right? So let's say you have a scale from 0 to 1, right? And let's say 1 is like perfect, or that's some threshold that you think is an important threshold, right? And if you want to show that, your data, whatever it is, maybe it's companies' performance, maybe it's country scores on some democracy score or whatever, if you really want to emphasize like how bad they're doing by saying, hey, look, this is the range and we could be up here and look how bad we are, right? Then it makes sense to leave the scale, right? But if you just try to understand like the relative differences between several countries, it's basically a waste of space to not shrink the axis. Yeah, and again, the important point is, so for instance, if you use a bar chart, right, to compare, then by shrinking the axis but still making it start at 0, you're not fiddling with the length of the bars at all. So you're not distorting, right? So I think that the crucial thing to keep separate is the distortion, right? Which is basically breaking the correspondence between the quantity and the visual attribute. That's bad, right? Because again, the whole point to visualize is to produce this correspondence, to translate numbers accurately in a physical stimulus. And if that encoding is broken, then you have a problem, right? And that's different from zooming in or emphasizing differences. Yeah. By making like a little difference, by looking closer, that's not cheating or anything, right? That's just taking a closer look, right? I think that's really important to separate these two things. Okay, Felix, do we have more questions?
Yes, we have some new questions. If you show the same type of plot for 2 different subgroups next to each other, I think it's important to show the same range of the axis to better compare the groups, right?
Yeah, yes, this is correct. And we will come back to this in 2 minutes. That's an important, so for comparison, definitely you want to have a fair comparison.
And then we have a question about the data ink. Does the decision on removing non-data ink limited by how obvious the data message is?
So I'm not sure I 100% understand the question. So if it's really obvious, well, in a way, yes. I mean, so if the data pattern stands out really obviously, right, then basically that's okay, right? It's just that most of the time, for instance, if you look here, if you have a bad data ink ratio, the problem will be that this will not be the case. Yeah. So, yeah, I don't know whether that answers the question, but in a way that's basically saying the same thing twice, right? A good data ink ratio basically means, hey, the data stand out. Yeah.
And then our last question for now, since you were mentioning ggplot, could you give your reasoning why you are not using it?
Because it's not a religion. That's my first answer. The second answer is maybe that's a generational thing, right? It just started out with base R when ggplot didn't exist. Are those good reasons? No. So I don't have a beef with ggplot2. I think it's a great tool. It's just like two things I don't like about it is that, and Hadley Wickham, clearly, I mean, he came up with it. He's a great guy, but I'm not a fan of reinventing things that aren't broken, right? And ggplot2, basically, the underlying logic of ggplot2 is the grammar of graphics, which is a very particular way to think about graphics, right? And along with this grammar come different concepts like the geom and the aesthetics, right? You know those labels. So basically, it's requiring you to learn a new language in order to do it. And I don't think that's something I would like to spend my time with. Whereas the underlying data model with base R is a very simple and intuitive one, which is basically the canvas model, right? Where you basically start out with something you put on the canvas on the screen, you just add stuff to it, right? So that's a very intuitive way to go about it. So that's one big point. I don't like to learn a new language to do what I want to do. The second point one could say is that some of the defaults in ggplot are just not great. I know this has changed, but previously, like 5 years ago, every ggplot graph would have like a gray background, which is not optimal, right? That's another point. What else? Another point is that I can do everything that I want with base R. So there's nothing I cannot do with base R. And I will show you later in the lab today in the afternoon how we can actually really mimic whatever design you have. We can construct it in base R. So again, there's no need for another language. And then maybe another more sociological argument is, it seems to me that everybody, especially the cool kids, everybody uses ggplot2 and you can tell. And I like to design my graphs in a way that maybe people cannot tell how it was done, but that's just a very personal. I think the more important point is that don't think too much about it. Just use the tool that works for you. I think that's really the underlying message. If you're great with ggplot2, just go for it. Use it as long as it allows you to do what you want to do. That's great, right? And if you're great in, you could even do everything. If you're really good in Excel, and you can do everything in Microsoft Excel, well, then just use this tool. Yeah. Think about also the principles. Ultimately, data viz is not about the tool you use. It's about what you learn from the data. Yeah. So those are my 5 cents on the thing. Yeah. Another thing that I could also mention is that once you produce more specialized graphs, and in R you will still have to use other packages, right? So it's not like you can just go to ggplot2 and think that's everything you need to know. So, right? So you need to learn other packages anyways. So I don't know whether that's answering, but that's just my take. Yeah. But again, don't make a big fuss out of it. Use what works for you. That's the larger message here. Okay. Felix, more questions?
That's it for now. Thank you.
Okay, that's good. So I think we have a good half an hour to go until the break. Yeah. So I think I got warmed up a bit. I was really distracted by the dog in the beginning. Whew. Yeah. So let's talk about comparisons. Okay. So if you think back about the fundamental principles of analytic design, so we want to visualize to help our analytical thinking that what we really should do, we should focus on comparisons. So what I would like to spend the next, let's say, half an hour is really discuss with you some some methods to come up with clever comparisons. And I think that some of the tools I will show you now may be new to you. I hope at least that you're getting something out of it that you don't know already. Okay, so let me just quote Tufte, why not? I mean, he's the guru, right? And he says, the fundamental analytical act in statistical reasoning is to answer the question compared to what, right? So comparison is the key. And he says, so whether you are evaluating changes over space or time, searching big databases, adjusting and controlling for variables, designing experiments, specifying multiple regressions, or doing just about any kind of evidence-based reasoning, the essential point is to make intelligent, appropriate comparisons. Okay, so again, I mean, that's what I said. That's the most fundamental thing everything's about, right? And therefore, if we want to use visualizations to help us in analytical thinking, what we should do is we should show comparisons. Okay, so let's think about some of the comparisons that we can do visually, right? So we could compare before and after. Yeah, so many things like in a policy field, did a policy work or not? Like, you know, in the policy evaluation, what was the state before? What is it after? Has it improved or whatever? Comparing to a standard, right? So we want to compare, for instance, whether some companies, you know, comply with some standard, whether countries actually, you know, have a certain democracy level. Those are important comparisons, right? Another important comparison is to context, right? So we just have a quantity for its own. It may not be very informative. Yeah, for instance, if we have just some score for the year 2021, but we don't know the context of how the score looked previously, then it's hard for us to understand. Then, of course, ultimately, like in the social sciences, we're all about comparing subgroups, okay? And subgroups clearly is like, could be anything, time points, countries, companies, social groups, demographic groups, whatever, right? Comparing across groups. And then something that's a bit more tricky and maybe not so obvious is we can compare to an implicit model, right? So if we look at the plot and if we see a pattern in the plot, we usually see a pattern because we're implicitly comparing it to the idea of no pattern, right? So think about a bar chart which has different length of bars, right? There you would say, hey, there's differences. And how do you come up with the idea that there's differences between the groups? Because the underlying implicit model is a flat line. Everybody's the same, right? So, well, I mean, I'm happy to talk about this more, but let's spend a bit more time here on some of the designs that are helpful for making these comparisons. And for each of those designs, or in general, if we want to compare, it's one decision we have to make is whether the comparison should be made within a single visualization, a single graph, or whether we should use multiple graphs, right? And there, if we use multiple graphs, and that's what one of the commenters actually came up with, is then of course there's certain practices that we have to follow, right? If we have multiple graphs, the graph should be of the same size and use common scales, right? That was the comment of one of the participants, of course. And then helpful alignment, the way we arrange the multiple graphs can help us in comparisons. And then finally, of course, we can use color and shape to compare groups within and across graphs, right? Basically, color and shape can be used to distinguish groups. That was also a question or a comment of one of you participants. Okay, so let's start out with before, after, okay? And what I'm showing you here is a slope graph, okay? And that's an invention by Edward Tufte, okay? And basically, what it is, it's a fancy version of a line chart, okay? So I'm showing you here, the numbers, what they are, those are probabilities that if you pick two random persons in a region, what's the probability that they will be of a different religion? Okay, so that's the underlying data here. So that's religious diversity. And now how a slope graph really works is it's basically showing change over time before or after. So we have two time points, 1910 and 2010. So we have a 100-year span. And now we can compare what was 100 years ago and what is now. And then basically what we have dots that show the quantities for each year, right? And then you just connect the dot for each observation, right? So, and you can probably guess why it's called a slope graph, right? Because you see the size of the slope is basically showing you the change from before to after. Like if it's flat, there's little change. If it's very steep, then there's great change, right? And what we see here in this graph is that the increase in religious diversity has been largest in Western Europe, right? So in Latin America, for instance, the slope is a bit flat. It's a little rising. Asia, it's a little rising. Although we have to say that Asia already starts at a high level of diversity, as does Africa, right? But the greatest increase is in Western Europe. Yeah, and that's a great tool to compare, to compare change over time, before and after. Any comments or questions regarding this visualization? No? I mean, actually, we could also think it, so the way I'm framing it here is as a comparison between before, after, but actually this graph actually allows for many more comparisons. What are some of the more comparisons that we can make? Well, clearly we can compare the levels within a time point. So for instance, if we go back in time, we could say, well, there's, let's say, 3 clusters or 3 general regions. So there's the low diversity regions, which would be the Americas and Europe, the high diversity region, Asia, and somewhere in the middle, right? So we could make this comparison within a time point across regions. We could also make the same comparison for the second time point. Clearly, we can make a comparison within each region over time. That's the before, after. Right? And as I said, we can actually compare the changes, the rate of change between regions, right? So lots of comparisons possible with this little design. Yeah. And in the end, it's nothing more than a well thought out line chart, really. Yeah, and it's also very easy to construct. And we will talk about construction in the afternoon.
We now have the same question, I think, 3 times. So this graph seems to assume that the slope, that the growth was linear over the 100 years. Isn't that a problem?
That's a great question. Is that a problem? Well, it's, again, as always, it depends on what you want to know, right? If you just want to know, hey, how was it before and how is it now? Then basically that's a simplification, right? So, so you could say, so by just focusing on 2 time points and just having straight lines, in a way, what this is a trend model, which is clearly losing a lot of detail, right? So it could actually be, I mean, this could be a curve here, or it could be like an exponential growth, or whatever, or it could be just wiggly and whatever. So that's lots of detail that you lose. And if that's something you care about, then yeah, you're correct. I mean, then that's maybe not good. But what's the benefit of it? It's like a clearer image of the most important comparisons, right? And then if you really care about, well, what has been the change 100 years before and now, if that's all you need to know, right? In a way, that's also the principle of just focusing on the most important data points, right? So that's also basically a design principle. Yeah? Get rid of data points that are not important for your story, right? Is it really important that there's some up and down movement? Is it really important to have that it's a bit, it could be for your problem, right? For instance, it could be important if you, it could be important if you try to understand why it is the case, right? So why is it the case that that Western Europe has this high degree? So maybe there are some critical periods, maybe there's a wave of immigration, for instance, right, which explains this jump. If that's what you're after, then you're correct, and maybe this would not show it, Yeah. So again, the overall answer is it depends on what you want to do, right? Think about the triangle. So what's the problem you want to focus on? And that's how you construct a graph. Other questions?
I don't see any yet.
Okay, then maybe let's go on. Let's look at the bullet graph. So the bullet graph is a graph that was invented by Stephen Few, another database expert that we already mentioned previously, right? And in a way, the bullet graph is the fancy cousin of the ordinary bar graph, the bar chart, okay? So, and what the bullet graph allows us to do is it allows us to make good comparisons to a certain standard, okay? So the components of a bullet graph are really that you have a quantitative measure that you care about. For instance, you could think about the revenue of your company, right, in US dollars. And then you want to compare it to certain standards. And one standard would be one or more related measures. So some target that you would like to reach, or some measure in the past, or some other comparison standard, right? And the way this is visualized is by adding an additional plotting symbol. So basically we have here, what we have here, that's just a bar, right? And that's clearly, I mean, that's just showing the quantity, but then you can have a little plotting symbol to show the standard, right? And in this case, let's say this is the target you want to reach that you set yourself for your company, and then you could immediately see, well, that standard, right, that target, that threshold was actually met. Okay, and then in addition, what the bullet graph also allows you to do is to compare the qualitative measure to define ranges of some qualitative state. Okay, so do you see those color regions here? So those regions could be, you know, you could define them qualitatively in the sense that, well, that's a poor performance, that's a satisfactory performance, that's a great performance, right? So and now with this little bar, you can make two comparisons to a standard. Did I meet my goal? Am I better than in the past? Or, you know, whatever that threshold is, and where am I qualitatively speaking, right? So it's just it's a fancy version of a bar chart, right? And it's basically just, well, what is it? Well, the regions are a bit tricky, but other than that, it's kind of like combining a bar chart with a dot chart. Yeah, and that's what I mentioned previously. Clearly, our basic building blocks that we use are dots, lines, and bars, right? But we can combine them to produce new visualizations, right? And then what we can also do, of course, is we can do this for one quantity, but we could also do this for several quantities, right? So again, if that's your company, the revenue, your profit, the average order size, the amount of new customers that you got in the year, the customer satisfaction, right? And now, so for instance, we could see like, you know, the goal, the profit wasn't reached, you know, there are not enough orders, not enough new customers, but, you know, in terms of customer satisfaction, you actually reached your goal. We see that the targets are all set in the good category. Clearly, you set your goals, you want to be good, right? But then we see, okay, at least what's good, the revenue is good, the customer satisfaction is good, profit is satisfactory, as is the number of new customers, but really the orders, those are poor, right? So that's the thing where you need to improve, right? And what's really interesting here is implicitly what this allows you to do, right? Not only compare to a standard, but it also allows you to compare across very different scales, right? So revenue is measured in thousands of dollars, profit in percent, right? New customers is just a count, and then there's a rating here for customer satisfaction. So very different scales, but you can even compare across those scales, right? And you could say, well, profit is not as good as customer satisfaction, for instance. You know? So that's actually a very neat little visualization method. And then for the lab, I actually have a little, you know, demonstration of how we would construct this in R, right? So I'm pretty sure that by now there's a package to do it, right? But we don't need a package because we can actually just reconstruct it. Any questions to the bullet graph?
In the meantime, we have 2 more questions about the slope graph.
Okay.
The first question, is such a graph well suited for a pre-post type experiment done across multiple groups? And the second question, would a bar chart do this job as good as the slope graph for the given example?
Okay, that's a great question. Both questions are great. So let's start with the bar versus the slope graph, right? So basically, you have 2 bars, one before, one after, right? And then you would see, hey, there's an improvement, there's a decrease, right? So this is something you could show easily, right? I think where the slope graph would be better is as the number of comparison increases, right? Yeah, that would maybe be more efficient in the slope graph. Yeah, and to think about this is that a slope graph is actually reducing complexity, okay, in terms of chunks of information, okay? So if you have 2 bars, how many chunks of information do you have? You have 2, right? 1 bar and the other. Whereas if you have 1 slope, right, you show the same trend, right? But it's less complex because it's just 1 chunk that you're using, right? So, and therefore, by reducing the complexity, you can actually show more group comparisons. That's maybe one thing. The other point is, again, think about the problem with this starting the y-axis at 0, right? So that would be problematic clearly in a bar chart. You couldn't do it. So if you have very small differences between the groups, it could be that they would not show up in the bars. Yeah, because the bars would show really tiny differences, but the slope, you don't need to start at 0, so you could zoom in and actually find a difference. So that's maybe an advantage. What else? I think that's pretty much it. And in terms of whether we can use this for an experiment shown before or after, absolutely, right? But actually, if you're just interested in, that's also an interesting thing. If you're just interested in the effect before or after, what you could do, instead of showing before and after, you could just show the difference, right? So, and then basically you could also, instead of having 2 bars for the first quantity and the second quantity, like the first experimental, whatever it is you're measuring in the second, right? You could just focus on the difference, and then you would just have 1 quantity to show. Well, of course, if you just show the difference, you lose the sense of levels, right? Yeah. So if you just have a difference of say 30%, you don't know, well, is the difference between 0 and 30, or is it between 60 and 90, right? And this could be potentially important. And this is actually something you can also show in a slope graph. Right, the slope graph shows the 2 values and the effect. Okay, more questions?
A question about the bullet graph. Is it widely used in political science?
No, no, and that's why I'm telling it. That's why I'm teaching it to you. I think it ought to be used more. I think it's a very helpful visualization. I have not seen it much. Yeah. Which, of course, then comes with the problem, do people understand it, yes or no, right? But I think because bars are so easy to understand and people know bars, it's probably not so hard to understand them, but who knows? Other questions? So actually, I'm not sure, Felix, so we looked at all the graphs in the HAPS. I'm not sure we ever saw a bullet graph in there, right? So be the first one to use it. Other questions? That's not
for now, I guess.
Okay, then let's just go. I think we're doing actually quite well in time. That's mainly because we're not having so much discussions in this format, but I'm actually pleased about that. Okay, so let's start about comparing to a context. And then we can use spark lines. Spark lines are an invention, again, by Edward Tufte. Yeah, and basically, I should say that the basic idea of spark lines is actually to use very small line charts that can be placed within a text or within a table. Yeah, you probably haven't seen that much, but you probably, so if you have stocks, you look into the newspaper to see how your stocks are doing, that's a common way to visualize it. Yeah, so the idea is really behind spark lines is really actually to have line charts that shows a trend over a quantity in a very condensed space, right? Which can be integrated in text or a table. Yeah. Why I'm bringing it up here is that I think that it's a great way to demonstrate the idea of comparing to a context, okay? So here, what if we measured your blood sugar and we came up with the glucose level of 6.6? And you're not a medical doctor like me, so I have no clue what that even means, to be honest. 6.6, okay, is that like good? Is that bad? Is that, you know, if I'm a patient, I need more context to actually be able to judge it. Yeah. And one way would actually be to place this quantity in the context over time, right? And there you would see, oh, here, that's where we are now. Okay, it kind of increased over the last, let's say, days, but it actually went down because previously it was really up, right? And there was some fluctuation. Do I now get a better sense of the glucose 6.6? Well, clearly it's not a maximum, it's not a minimum. It seems to be somewhat of a middle, like kind of an average value, right? At least within the observation, right? So then a little design feature to make it stand out more is you can use pre-attentive attribute of color, right? To actually highlight that this is the last value you care about. And then you link it by a color immediately, then it's clear, oh, that's 6.6. And then again, this is showing the context of your number, okay? And then we could also, I mean, we can actually also combine context and standard as before. For instance, again, asking, well, 6.6, is that, you know, is that average or is that like in a dangerous range or whatever? You could actually have this little gray band, which gives you the normal range, right? And then what you could say is, well, first of all, the current blood sugar level is normal. It's well within the normal range. But look, you were really under sugared a couple of days ago, and then there was a period where the blood sugar was really high. Okay, so now you can even judge this better, right? And get a better sense of the overall. Yeah, this, in a sense, this is also providing context for your quantity. Yeah. I mean, this is just a variation in design. And then what you could do, you could also use the spark lines to compare across variables, right? So for respiration, temperature, right? And again, those are on different scales, but you can get away with comparing them. So you could say, well, everything is basically in the normal range now, right? But we saw that, you know, there was some abnormally high activity previously. Yeah. Does that make sense? Yeah. Any questions to this?
We have a general question. Do you think there is a general difference across disciplines in terms of what's accepted in terms of graphs, maybe because of traditional thinking? And is there a difference to what is recommended by the database community?
Yes, I'm pretty sure there is. So I would say probably, but you know, things have changed. I would say that the hardest discipline for graphs is probably econ, because economists, they think that's not serious data analysis, right? And that actually goes back to even Keynes or whatever. It's like, no, you know, we're not looking at pictures, we're doing serious science and it needs numbers and tables. So I think it's harder in econ than in let's say political science. I think like among the social sciences, I think political science so far is the most friendly to visualizations. Well, I think the important point, of course, is that it's a mistake to think that that visualizations is not for It's not scientific, but easy. Because if you look at the natural sciences, actually the natural sciences, life sciences, physics, what have you, are actually very visual. Yeah. So if you look at nature or science, if you look at those articles, they have lots of visualizations. So it's clearly wrong to think that using visualization is a sign of a soft science or whatever. Yeah. So I would say, yes, there's definitely a difference in disciplines of how common it is to use graphs. Yeah. And yes, there are, of course, certain graphs are more common in some disciplines than in others. Yeah. Let me think of one. For instance, heat maps. You know what a heat map is? We basically had one before, like with the colorful dots, you know, where I said you cannot compare the height, you know, the reds and greens and blues. I mean, heat maps are used in gene expression data, biology, right? Used a lot. People understand them. I think they're a bit harder to understand in the social science. So I could come up with examples where, yes, right, certain disciplines have certain visualizations that they tend to use and know well. Yeah. But ultimately, I think it still boils down to everybody understands a line chart. Everybody understands a bar chart and uses them, right? And dot charts as well. What was the second part of the question, Felix?
If it's against or if it aligns with the recommendations by the database community.
Yeah. I'm a bit hesitant because the database community is not one homogeneous community, but it's different, like has different branches. So there's like statisticians among them, there's computer scientists, there's designers, and they probably, even they wouldn't agree on what it is necessarily, you know, what's important. And then if you ask whether overall the disciplines seem to follow the recommendations. I mean, you see lots of awful graphs, that's for sure. I mean, that's something I didn't do today. Usually what I do show in class, I show like horrible examples of like published research, which basically answers the question that, you know, no, I mean, many people don't follow the recommendations, but I think it's getting better. It's getting better.
Then we have a question about these spark lines. Is it possible to add access to these spark lines, or does this have to be explained in the text? For example, on the slides, this could be across several days, months, weeks, and so on.
Yes, that's a very great question. So the whole idea of the spark line is actually not to provide exact numbers, except for the quantity that you really want to show, right? That you focus on. So 6.6, that's quite exact. But the whole point here is not to give like an exact number, what's the maximum, what's the minimum, but it's more to give a sense of the pattern, right? And therefore, the whole idea is to not have axes, right? So you don't need them with a spark line. However, there's two axes, right? There's Y for the quantity, and then there's X for time, right? And then clearly you would need to say, at least like in a table, do we have it here in the table? It says assignments 1 to 5. Here in the text, it basically gives a date, right? So of course you need to tell, well, what's the range, right? Are we looking here at minutes? Are we looking at days or even months? Yeah, that's a context that you need to provide with the spark line, but you wouldn't do it with a classical x-axis and a label. Yeah. Yeah. Any other questions?
I don't see any. Thank you.
Okay, great. So then we have 6 minutes left, and let's see whether we can get this done in 6 minutes. Comparing subgroups and the small multiple design, okay? If there's one method, so if you guys had to pick like just one thing that you should take away from this course is probably the idea of small multiples, okay? Because I think it's a very powerful design to make clever comparisons across subgroups, right? And so what's the idea of a small multiple? Basically, the idea of a small multiple is to have one graphical format, which you repeat for different subsets of the data, okay? And why it's called, so that's the multiple part, So you do the same thing, the exact same thing for different subsets of the data. In this case, in this example here, the different subsets, the subgroups are the countries, right? And the idea is to also make the single graphs very small, right? To shrink them down so that you can make lots of comparison and you can fit lots of them in a single screen, right? So that's the basic idea of a small multiple design. Here, this example is actually from the New York Times, and it's showing, what is it showing? Median per capita income after taxes, right? And in a way, what it's showing for each subset, it's a line graph showing how in the country the income has changed. And then we also have an comparison to the US for each country, right? And then it's arranged, and then you can neatly compare across the panels, across the multiple graphs. And then you can basically say, well, income is high in Canada and Norway. It's lower in Ireland and Spain, but they have seen a stark increase. What else is to be said here? I will have another example. I mean, here, of course, the question comes up, if we want to do this experiment, this comparison, is it good to have like multiple graphs, or could we have done the same comparison in a single graph, right? And here I'm just, I'm just trying to mimic the design, didn't have the data to actually reproduce it. I mean, that's what we saw before, the small multiple design, right? And this is what you could also do, like you could use all the lines in a single plot, right? And then the question is, well, what's better and for what purpose, right? Clearly, separating out by subgroup allows you to have a better between subgroup comparison, right? So you could use this country and compare it to this. You can compare it to this. You could also compare this country to this like baseline, if you like, to the US, right? So the between group comparisons are much easier if you single out the groups and arrange it in a neat way. Whereas here, it's really hard to compare like a single country. I mean, first of all, you would need to know which country it is, but then it's all cluttered up, right? So this line, this chart would probably be better if your goal is to compare the US to the rest, right? So this is a different comparison. Also note that I'm using the color differently. So what stands out here, what's popping out are the single countries. So that's the focus, right? That's what we can compare. Whereas here, the focus is on the US up here, and then we can compare it to the rest of the countries, right? Which is a different, I mean, again, it depends on what you want to do, okay, so that's another example of a small multiple design, right? So what it is, it's basically a map, a core path map, okay, of the United States. And here, each state is colored. And now for the colorblind people, that's actually not a great plot because it's in green and in orange, right? So with the green up here and the orange here. So, and this is showing support for the school vouchers, okay? And now the idea is that we repeat, and clearly you see a geographical pattern here on the map. That's why you have a map, to show a geographic pattern. And now to turn this into a small multiple design is you repeat the same size. First of all, it's a really small map, but you now repeat it multiple times, right? And you do it by repeating it for different subsets, right? Different subgroups. So up here, we would have different voter groups. So up here, the first row is all voters, and then we have religious and ethnic categories: white Catholic, white evangelicals, white non-evangelical Protestant, white other, no religion, blacks, Hispanics, other races, okay? And then here in the columns, we have income brackets from the poor who earn below $20,000 a year to the very rich, over 150,000, right? So those are different subsets. And now what you can do is you can see the spatial pattern in the support, right? Notice how many variables are in there. Spatial patterns in the support across different subgroups. Yeah, and what we see here, that's kind of counterintuitive. Green is actually against school vouchers, and orange is actually in favor of school vouchers, right? And then what we see is that white Protestants and white non-religious, they're against school vouchers basically all across the country, right? And also in all income brackets. And then what's interesting here, that's actually an interaction effect. So for Blacks, it's really interesting, is for the Blacks, if they're poor, then they're in favor of school vouchers, especially here in these regions. And then if they are richer, they are against it, especially in the South, right? So this is showing, in a way, this small multiple design, what this is actually showing a complex interaction model. Yeah. But again, the underlying idea is use one format, repeat it, right, for different meaningful subsets and rearrange it in a meaningful way. Here are some of the rules, right? As before, you need to have constant access scales so that the comparisons work. Let's increase the data ink ratio and have a sensible ordering, okay? And this will be my last example before the lunch break, or not the lunch, we won't have time for lunch, but the coffee break. So here, what I'm showing you here is a small multiple design. Again, it's a line chart, so to keep it simple. And what this is showing you is political rights over time. Yeah, I think it's starting in 2004 up to now, right? 4 different, so it's 36 countries, right? And basically how the political rights in the country have changed. This is the raw design, and of course it's problematic. So we see lots of movement, right? So, but is that really realistic? No, what we should do is we should definitely have constant scales, yeah? And once we have constant scales, oh, that's much more informative, right? Because all of a sudden you see that many countries are actually flat, right? There's not much change in political rights. But then what happens is that the countries that do have changes in political rights actually pop out here. Look at Thailand, for instance, right? So look at this decrease here. Look at Tunisia, right? This increase here. Of course, you know, if you're political scientists or just politically interested people, you know some of the events that are maybe related to these changes. Yeah, so that pops out now, okay? But it's still not optimal. So let's increase the data ink ratio. So what should we do? Well, let's push out the data, which would be the lines, and everything else is not so important, right? So let's put it into the background by making it gray. Oh, much better, right? You see it? Oh, we also see in Burundi some movement, in Madagascar. Okay, and now we need to come up with a sensible ordering, right? So I think now it's really now it's really random, right? But let's order it by average political rights. And this is what would happen, right? And is there something that now you see immediately, which really facilitates the comparison, the ordering? I think what's really interesting is that if you care about stability, there's really, the really stable political systems are the high, like the democracies with high political rights, they're stable. But then the dictatorships are also pretty stable, right? So they're just on a low level, but they're stable. And then you see, yeah, here in the mid-range, that's where the most change happens, yeah, which is now very neat. You can see it clearly. So if you compare this, it was a bit chaotic. Now it's a clear pattern. Okay, folks, I think that's what I have for you in terms of concepts and theory. Should we have a final round of questions, and then let's take a 15-minute break, but I want to get in some questions. And then, you know, in the next 2 hours, then we will look into R and produce some graphs ourselves. Okay.
Okay, the first question, why changing it from gray to pink would increase the data ink ratio?
That's actually a very clever question, because the amount of ink doesn't change, right? Well, unless you could say you need more ink for black than you need for gray, right? But you know, look, it's not, that's the important point here is what stands out and what is in the background, right? And bright pink clearly is pop out. This clearly stands out. I could have done it in black, yeah, but this is, in a way, I have no, so look, what I could have done is to just increase the data ink ratio by making the lines black, right? And then I could have saved pink for the interesting cases. For instance, I could have highlighted Thailand, yeah? So in a way, I'm a bit wasteful with my resources here, yeah? But basically all I wanted to achieve is to push some of the things that are not important into the background, right? And just let the data stand out. Yeah. So in this sense, it's basically just two layers. You know?
Another question then, would it be possible to just put the axis at the bottom of all the plots and to the left of all the plots because it's the same for all the individual ones?
Yes, yes, yes. Yeah.
Then,
although I have to say, yes, absolutely. And that would probably make sense if you have it like this, where it's like really like distracting. I would say that once you put it into light gray, it's not as distracting anymore, right? Such that it does, I mean, you can still see it clearly, but in a way it's redundant, right? You don't have to repeat it all the time again. So that's correct. You could just have the x-axis on the lower and the y-axis only on the first column. Yeah.
Then about the usage in comparison to a single plot, which I think you showed at the beginning, are small multiple plots the better option when subgroups cross over each other significantly or frequently, as opposed to groups that are clearly separated?
Yes, I think that, yes. But again, it depends, right? So if you want to show like an overall trend, so if you want to show a global trend, right, where you would like to show, well, what does the world look like in general? Yeah, then you could put it in a single plot. And then you would also see lots of crossing, right, which would tell you something. This would tell you there's lots of movement going on, right? So that's what you would do for the overall image, right, for the global image. But as soon as you're interested in single trajectories, it's best to single out the countries. Although you could also get away with something in between, like comparable to this here, right? So you could show all the countries in gray that you don't care about, and then just show the one country that you really care, the trajectory that you really care about. And by the way, this would also be a way of showing. The way I framed this here, this is comparing across subgroups, but this graph here is actually also a way to show context, right? Because it's showing the context, the world context of your single country, right? Does that make sense? So any other questions?
We have one last question to the spark line. Isn't it a bit unsatisfying to not show the acceptable level of the glucose in the spark lines? It only communicates whether 6.6 falls within the range band as acceptable range.
Can you repeat the question, Felix? So because the band could basically mean that that's the acceptable normal level.
The question is if it's not unsatisfying to not know what exactly the range of the green or gray band in the background is.
Well, you can give it. I mean, you like in print, like visually, it would, since it's so small, it would probably be hard to give it, right? But you could provide it in the context, in the text surrounding it. You could say, well, that's the range. Yeah? And then the question, is it satisfying or not satisfying? It depends on what you want to know, right? Is the important point to know whether glucose levels of 6.6 is within the normal range, or is it important to tell somebody who's not a medical doctor what the range of normal would be? right? So that's a question, how much, so in a way that's also linked to the idea, is every data equally important, right? But if you're worried about this, like in a lab, I have one example where we would actually do like a range of normal, where we can label the normal range, right? So in principle, I mean, it's not a problem. It really depends, is it necessary for your particular context of application?
That are all questions for now. Thank you.
Okay, so should we take 15 minutes break and be back at 12:25? Yeah. And then we'll go into the lab. Okay. Let me stop here.
I come from Kathmandu, and then Kathmandu is not just densely populated, but kind of a jungle of concrete, and we don't have any open spaces and very narrow roads, and then traffic congestion is horrible, and then we have a very poor public transportation. So in contrast to that, here there are amazing parks where you can run, where you can, walk, and then just lay down and read. I'll be looking at South Asia and Europe, especially. I'll be focusing on EU and SAARC, and I'll be looking at why it worked for EU, why EU succeeded, and why SAARC failed, because even after the 35 years of establishment, we have failed to deal with various situations. We still have trade barriers, we have failed to curb the terrorism and poverty, and we still have the complicated border issues. So that's the reason that I wanted to pursue my PhD in this. I have to read a lot, so it's kind of much, there will be a lot of... And I'll be looking at the factors what made EU work and what models can be adopted from the SAARC. It's a kind of comparative studies, so I'll be looking at the historical factors as well in EU and South Asia, and I'll be comparing the historical factors. Why did it work for EU, and why is it not working for Pakistan and India? For now, yes, I have a plan to do my field research in Brussels, in EU headquarters. I'm not sure how feasible that would be. And also in SAARC headquarters in Kathmandu, and in New Delhi, where most of the South Asian scholars are available. I'll be going with both the qualitative and quantitative, but yeah, obviously more qualitative. I think that would be quite interesting because script is already supporting, as you said, like script is already supporting the combination of the both social sciences and area studies. And I hope to, achieve more by getting involved in this program in terms of my knowledge and then in terms of theory and all. I thought that this would be the right choice for me if I get selected, because because I learned that scripts promises to deliver really rigorous academic trainings in collaboration with the other renowned academic institutions. That was the first reason that I was interested in scripts for my PhD. And the other reason was I felt like I realized that it encourages the interdisciplinary teamwork. I did my master's in South Asian studies, and before that I did my bachelor's in sociology, and I did my post-graduation in human rights too. I did my master's from Pondicherry University in India, and my post-graduation also from Pondicherry University, India. Here, I think it would be field enough to add that I worked as a journalist for nearly half the decade, like 5 years in my country, in 2 leading Delhi newspapers in Kathmandu. We all have different sort of perceptions and we all have different experiences, and in terms of research as well. And with postdocs, obviously, they have already encountered this, they have a broad range of experience. So there is a lot to learn from them and to hear from them. But even with my colleagues, like, they come from a very different, as I told you, like completely different sort of backgrounds. And yeah, in both ways, it's kind of a learning experience.
Okay, people. Let's go back. Share screen. Let's wait one more minute for everybody to arrive. Okay, so 12:25. So people, now let's talk about how to do some of the stuff in R. But maybe over the course of the coffee break, were there any questions left that you would like to have answered? Any questions? Okay, so now we have a good, like almost 2 hours to look into data viz in R, right? And here now, I know, since I have no clue who you are and what your skills are, I thought it would be a good idea to maybe give you some options of what we could do. So many of the examples, you know, are not like, won't take much of the time, so we can definitely do some of them. But I thought it would be a good idea to first do some very basic stuff in R for those who are not familiar with it. And but if everybody is familiar with it, then we don't have to do this. Yeah, so that's the stage where I would really appreciate some feedback or some preferences that you guys may have, right? So if you're already very experienced R users, then maybe we can just focus on doing some of the things. So here on the menu are 5 things. So I would walk you through some basics in R, right? Basically building a plot from scratch, touching upon some of the things that we have discussed. Then what I would like to show you is how, once you know R and also base R, you can build any plot that you would like to plot, right? And I think that's the main thing why R is such a powerful language for data viz, because you're not dependent on what the software provides. You can literally do and reconstruct whatever you want. And I will demonstrate this on the bullet graph that we talked about. We can also have fun with a bit more pop visualization and try to come up with a joy plot map, right? If you know you may know those designs. They are mimicked after the Joy Division album cover, right? So it's very popular in the data viz community. So we could come up with a neat little playful example here. We can also talk about exploring whole data sets using table plots, right? Which is maybe a bit more techy, but also not hard to do. And then maybe some of you would be interested in visualizing statistical models, okay? And we could talk about this, although I have to say, you know, basically so far, we're really interested in visualizing raw data, right? And if we want to talk about statistical models, I don't know how much, you know, background you have in, for instance, logistic regression, right? And I know, obviously, I wouldn't have the time in this course to actually go into the details of logistic regression. I would have to assume familiarity. So I'm not sure whether it's safe to assume that. Yeah. So let me look in the chat. Are there some preferences here? More, it says starting basic would be great. From YouTube, everyone also says starting from the basic would be great. It would be very interesting. Okay, Christina. Okay, so in any case, then let's start with starting basic. Christina, for you, if we don't have the time to get to statistical models, you know, you will have the slides. You have the link to the slides and also the code, right? So I hope you have access to the Dropbox link. I hope there's 2 scripts here. One is for the basic stuff, and then the other script is for all the other things that we're doing. So Christina, if we don't have the time, at least you will have the code. It's more or less reasonably documented so that you could work through it by yourself, right? So in any case, you can take something out of it, yeah? But if everybody is here, wants to do the basic stuff, that's great, yeah? Okay, and I think the way to do this, also there's a choice here. I mean, I have slides and maybe it's good for you to just follow along, right? Oftentimes, I think, people learn this stuff by actually doing the stuff by themselves. I don't know, you could just follow along the slides. I think it's better if I just show you the slides. I could also switch to R and actually do some like live hacking. Let's see, let's be spontaneous about it. In any case, feel free to comment or ask and interrupt. And then I may actually switch between the slides and actually doing stuff in R. Okay. Okay, so now for you, all of you who are so into ggplot, we're not going to use ggplot, but let's just use base graphics, which basically comes with a plain vanilla installation of R, right? I gave you my reasons why I think it's a great place to start and even stop, right? Because you can basically do most of the stuff that you would want to do. Briefly, to get a first understanding of how base graphs works is, and I assume that by now you have some familiarity with R from a previous summer school course, where the basic idea, of course, is that you have data objects like vectors, matrices, scalars, and you apply functions to those objects, right? So that's the basic underlying idea of R, right? And now when it comes to graphics, there's three main functions, if you like, that are important. The first are what I call high-level commands, right? And those are functions, right? And functions usually have names and then parentheses and then stuff that goes within the parentheses. And those high-level commands, what they will do is they will create a whole plot format, right? So this will create a scatter plot. It will create a complete bar chart, for instance, right? And then we have low-level commands, right? And what the low-level commands do is they add elements to an already existing plot, right? And previously I said, when I discussed, why base R, that the underlying model you can imagine is like being a painter who has an empty canvas, right? And you just start with something, you just put it on a canvas and then you add elements to it, right? And how to add elements to an already existing canvas, if you like, is using low-level commands. So for instance, you could add points, lines, texts, whatever. So, and in all functions, of course, you have arguments and parameters, right? Which allow you to define and fine-tune various elements within the plot. So the color, the size of the plotting symbol, etc., etc. Yeah, and the way this works usually is, again, you have commands with names, then some data object that you apply the command to, and then some arguments, right? And then if you want to produce a whole plot, what could be is that you first set some parameters with some arguments, then you produce a first plot, right, with a data set and some arguments, and then you just add stuff to it, okay? So, and now I have here in the YouTube, by popular demand, it would be great to see live coding in R, which is always a risk for the instructor, but I'm happy to do it. So if that's what you want to see, let me do the live coding then. Let me do the live coding. And let's hope that this works. So let me stop here my slides and let's jump to R. Can you see my R Studio? Is it okay? Yes? Is it large enough? Can you see the, is that okay?
It looks good.
Okay, perfect. So, okay, then let's get started with some of the basics. I won't spend much time. If you want to follow along, you have the script open. Let me see what's the, yes, it would be great. To white background. Is that better, white background? Those are really my preferences, people. But okay, let's do it. Appearance. Let's change to, what's a good one? No. Is that better? Let's use this one then. Is that better? White background? Yes. Okay. Okay. So let's get the working directory set up. Obviously, people, this is my path. you know, you have to change it to your path wherever you have saved your data set. So let me just run this here. Okay. So it already says, oh, there you have it. It's already, that's why I don't like to use the, that's why I don't like to use the live thing, because already now I'm having trouble with my own, yeah. Let's hope that this data set is in the Dropbox. No, it's not. Let me quickly put it in the, that's why I don't like to do the live thing. Find it. Where is it? Come on. So now we have it. Sorry for this. So we got the data in there. As you can see, if you are struggling with this, this happens. Don't worry about it. Now we got the Gapminder data set. Let's have a quick look at the data set. Okay. And you may know Hans Rosling and the Gapminder. If you don't do, I really encourage you, go to YouTube and look it up. Yeah. It's lots of fun. He's basically invented the moving bubble chart. So take a look at this. But what this data set really is, if you look here, that's a time series cross-sectional data set, right? So we have different countries countries over several years, right? And what we have in there, we have the country, we have the continent, the year of the observation, life expectancy, population size, and GDP per capita. Okay, so what we can do quickly is look at the class of variables. So for instance, let's look at life expectancy. What kind of a variable is it? Well, it's a numeric variable. So that's R, speak for continuous variable. What's the continent? That's a character. And that's already something I really want to change the character into a factor variable. Okay, and a factor variable is just it's just R's ways of saying it's a categorical variable. So let's have a brief summary of the life expectancy, right? Just some summary statistics here. The minimum life expectancy, and this is outrageous, right? But clearly, I mean, the data starts in 1950, I believe, is 23 years of age, right? The maximum is 82, right? We can also summarize, and the mean is 59 life expectancy. And then let's summarize the continents, and there you see most of our observations are from Africa, then many Asian observations and European observations. Again, those are country years, right? And then we can look at the table of the continent, which basically gives us the same summary. And then we could also do a proportional table, which doesn't show the counts, the frequencies, but basically the percentages. Okay. So that's not important, right? Because that's not actually doing the actual plotting. But as you can see, and I'm just repeating it for those who are new, look at what we're doing. We're using a function, right? And most of the functions have intuitive names. And then within the parentheses, we apply those functions to a data object. In this case, data is the data set, the Gapminder data set. And then with a $sign, what you do, you access the data set and tell which variable you would like to use. In this case, it's continent. Okay, so for now, what we want to do is let's focus on just one country to keep it simple. And let's focus on Afghanistan. Okay, so what we're doing here, we're looking into the data set and we're accessing the data set with the square brackets. Okay, so and what is a data set? Well, a data set is a matrix, right, with rows and columns. So basically you have two coordinates, if you like. You have the rows and you have the columns you can access, right? And what I'm doing here is I'm basically saying, hey, just give me all the rows for which this condition holds true, right? And the condition means data country equals Afghanistan, right? So basically, and then here after the comma, this would be the column. I'm leaving this off. So give me all the columns, all the variables, but only for Afghanistan. And then I assign this selection to a new object called AFG for Afghanistan. So let's run the code, right? And then we're ready with plotting, okay? So, and the first plot, the easiest is the plotting function, right? And that's really intuitive. If we want to plot, just use the plotting function. Let's just take the life expectancy of Afghanistan, stick it into the plotting function and run it, right? And then what you will see down here, there will be the visualization popping up, right? And it's just a single, that's just a single data series, right? Here the index, yeah, so we have 12 observations and that's the life expectancy. And we see for each year the life expectancy in Afghanistan and it went up, okay? So that's quite something, right? This little piece already gives us a first visualization. And now that's a high level function, right? Because it produces a complete plot already. In this case, it's a dot plot by default. Okay, and now, as I said, each function, uses a data object and then some arguments. And we can play around with some of the arguments by saying telling the plotting function, well, what type of a plot do you want? And the P would just be as before, right? This would just be with points. What happens if we say type L? It could be that it does a line, indeed, right? What if it's a B? That stands for both. So it will give us dots and a line. And if it's just an O, yeah, then it will throw the line through the dots. Then H gives us kind of a histogram, right? So S will give us stairs. And then finally, N will give us no plot. And there you will think, well, why is that useful for plotting data? How does it help? Having an empty plotting region. In fact, this can be helpful if you're constructing more complex visualizations from scratch, where you literally first want to set up the plotting region, right? And then just add manually stuff to the plotting region. Okay, so what happens? So we saw that life expectancy is a continuous variable, okay? And in a way, plot will know what to do with a continuous variable. What happens if you put in a factor variable and just into plot? What would happen is, by default, it would produce a bar chart, right? Where here we have the frequencies here, and here we have the different categories, right? So the plotting function already knows and chooses different default visualizations depending on the variable format. Yeah. Okay, so that's easy. Now let's look at some other high-level functions, and I'm doing this really quickly, guys, right? Because it's not, there's not much to it, right? I'm just doing quickly just to give you a glimpse of how easy it is to produce some basic plots, and then we will try to clean it up and make it actually look good, because arguably that's not attractive. So let's do a bar plot, okay? And to do a bar plot, what we could do is we could look at the table that we had before, the frequency table, turn it into a table of proportions, so with the percentages, and assign it to the new object calling myTab. So let's run this, right? And now if you look at myTab, what is myTab? Well, that's just this little table here. And then I take myTab and plug it into the bar plot function. And that's also a high-level function, very convenient name, right? Bar plot. Let's run it. And this would give you the exact same result as before. Okay, so now just to do some things, what we could do is we could sort the categories according to size. And usually we saw this in the small multiple design. Usually sorting is a very easy but very powerful thing to do. Yeah, it just makes the pattern cleaner. So what we can use is we can use the sort function and apply it to myTab. And what we're saying is sort it in decreasing order. So decreasing is an argument and it should be true. T stands for true. Good, let's sort it and then overwrite our MyTab object. Now, if you look at MyTab again, oops, should be down here. You see it? Yeah, now it's sorted, right? So it's Africa is still the first because it has the highest shares, but now Asia went up second, Europe went up third, Americas went back fourth, and Oceania, there are the fewest observations. So it's now sorted. And now if we put this into the bar plot, yeah, looks much better, right? Okay, so I'm telling you this is a function you can probably forget. Yeah, pie chart, really easy. You can use a dot chart. Yeah, very easy, high-level commands. Let's do a histogram. And now we cannot do a histogram on the continent, obviously, because a histogram is really showing the distribution of a continuous variable. The function is just called hist. If you run it, then you will see a neat histogram which shows distribution, right? And then you can, again, because it's a high-level function or like any function, you can specify some arguments. For instance, you can make the bins smaller, so to have more detail, or wider using the breaks argument, right? There you go. Now it's a much more fine-grained image, and you see the life expectancy seems to be bimodal. Really, there's lots of countries with high life expectancy, and then there's a group of countries with low expectancies, life expectancies, right? So maybe that's too much. That's quite good. This would, you know, if you make the bins too wide, this would hide the pattern, right? Again, I'm speeding over this, right? This is just to show you how quickly, with just one line of code, you can produce like out of the can the data with. Okay, let's have a box plot. There you have it. Okay, so here it says using two variables, but in the interest of time, I'm not doing too much here, right? So basically, of course, if you can plot one variable, you can also plot several variables. Yeah, what I will do is I will quickly run this code, which basically just, well, let me tell you what this does. I want to create a new variable called rich, right? So I want to divide up all the country years in rich and poor. And the way I do this is I create a new variable I call rich. It's attached to data. Then I define it in the sense that I say if else, right? So I'm providing, or I'm giving a condition here. And I say, hey, if the GDP per capita is greater than the median GDP per capita, then call it rich, else call it poor. Okay, so let's look at this. Let's run this code, right? And now if I look at, data rich, see, yeah, it's pretty much half-half, of course, because that's what the median does, right? It splits the sample in half. So half is poor, half is rich, right? Make sure this is a factor variable, and then I can plot it against continent in MyTab in a bar plot, right? And then here, the dark are the poor country years, and the light gray are the rich country years. Yeah, and we clearly see most of the country years in Africa are poor, like below the median income, like many in Asia, and then Oceania and Europe, most of the country years are considered above the median. Okay. So again, what I could do, now this is MyTab, what I could do, let's look at MyTab. So now it's a cross tab where we have poor versus rich for the regions, right? And what this is, those are showing column percentages. So they add to one column wise, right? And now what I would like to do, again, I would like to sort this, yeah, according to the rich, right? So what do I have to do? Well, I come up with an order. I want to extract the order of MyTab, right? And I want to have the order of the second row, right? So again, MyTab is a matrix, so it has rows and columns, and this with square brackets in year 2 says, give me the second row here, okay? So let me just show this to you so that it's clear. right? If I'm doing this here, so you see I'm just having one row now, and it's exactly the second row, right? So now I order this and create a new object, which is called ord for order. So let's look into the order object, right? It says 1, 3, 2, 4, 5. Yeah. So it's ordering 1, then 3, then 2, then 4, then 5. Yeah, that's correct, right? And then what I can say is let's now order the columns of this object, right? So I want to have the columns here, and basically I'm just saying so change the order. So I'm running this now. Look at my tab. Oh, here the order of the continents has changed again from the lowest to the highest, and then bar plot. Boom, so much nicer. Okay, so very basic. Now the interesting bit is that you wouldn't use the visualizations like this, right? You wouldn't publish them. You probably wouldn't show them to your friends. However, what you probably could do and would do is if you just explore data, you're completely fine with these designs. If you think back to the very beginning, what we discussed, there's two types of visualizations, right? Exploratory, analytical visualization versus presentation or explanatory visualization. And clearly, if you just quickly wanting to learn about the data, these designs are perfectly fine. You don't have to make them pretty or anything. Yeah, but as soon as you want to publish stuff, show it to other people, then you need to work a bit harder, and that's where some of the arguments come in, right? So I'm doing this very quickly for the bar plot, right? As you see, there's several arguments that you can use with the bar plot to actually come up with different types of bar plots. So let's just start. So we have this stacked bar plot here, which is kind of the default that R would come up if you put the cross tabs into the bar plot function, right? But we could also say, hey, why can't we have the orientation horizontally? So let's put it horizontal true. Let's see what it does. Oh, okay. It's not great, right? Those labels don't look good. If they're too long, they won't show up. But at least we now change the orientation. Now, this is a stacked bar chart, which basically stacks the two data series on top of each other. But maybe we would like to have a grouped bar chart where we can have the two bars next to each other. And the way to do this is to use the beside argument. There you have it. Now you have a group bar chart, right? So the poor, the rich, for each continent. Yeah, that looks nice. Can we have the same thing horizontally? Of course, because we can't just add more arguments, right? As many as we would like. Now we have a horizontal bar, group bar chart. Maybe we would like to have a legend. Yeah, it will put in a legend. And you know what? Maybe we don't like the borders behind the bars or around the bars, so we can just leave them off. Okay, guys, this is not intended, this is just, you don't have to remember anything of this. You have the code, you have the slides. This is just to show you, how in principle the coding would work, right? You have a high-level function, you put in a data object, which is a cross tab in this case, and then you just fiddle with arguments. And you can see, right, this already looks quite different from our initial bar plot. Yeah. So how do you know those arguments? Well, you have to learn them, right? And in case you don't know what arguments are actually allowed in a function, what you can always do is you can find help by typing question mark and then the name of the function, right? And then what will happen if you do this, what will pop up here is actually a very helpful help file, right? I know that help files are sometimes not helpful. In this case, they usually are, right? And what will happen is, what will pop up is a description of the function, what it does. So this creates a bar plot with vertical or horizontal bars. Then it will tell you how you can use it. And there you see all the arguments that are in principle allowed. And you see there's lots of arguments allowed where you can change, right? And then all of those arguments are actually explained quite well down here, yeah? So you can look up what those arguments mean, right? what they do. And you see there's lots of stuff. I mean, you know, this is you can do lots of stuff, right? And after a while, in the beginning, probably you will use the help a lot, but after a while you will probably remember the most important arguments and you don't have to go to the help file anymore. And then what it also shows you, it also has examples for you, right? And then you could basically copy and paste the code into your console and see how it works. Yeah. So when in doubt, check it out, get help. Yeah. Okay. So now the interesting thing is that some of the standard arguments actually work for all high-level functions or for most high-level functions. And these include the color of the plotting symbols, the size, right? And maybe the shape. Yeah. So what we're doing here, let's plot GDP per capita against life expectancy, right? Let's first do this alone. Yeah, so that would be the default scatter plot in R. Here, GDP per capita, life expectancy, and we see this weird shape here, right? So what if we wanted to do the plotting symbols in red? Then we would specify col for color and just type in red. We will come back to colors in a couple of minutes. Okay, so what happens if we do this? Oh, look at it. Yeah, it really pops out. That's neat. Maybe we would like to change the plotting symbols. Let's not have circles, but maybe solid dots. Okay, and I happen to know that I happen to know that solid dots are 19. Let's put 19. There you have it, right? And 17, what's 17? Well, those are triangles. I don't know where you would use triangles, but I'm just showing you that you can. If you wonder how would you know, on the slides, you actually have a little table which will provide you number codes, and then the plotting symbol, okay? So clearly we can change the two things at the same time. So we can change the shape and the color at the same time. So let's have green triangles, why not, right? Looks nice, not. And then we can also change the size. I should say PCH stands for plotting character, okay? So that's the way to remember it. And then CEX stands for character expansion. And basically that's just a factor, a multiplicative factor, right? Make it 3 times as large. Well, I don't know why you would use this. And then you could also specify colors. You could actually specify colors using the RGB color scheme, right? Which basically allows you to encode any color with its amount of red, green, and blue, right? Oops. Okay, it gives me a, oh, there you have it. Yeah, there you have it. Yeah, so the maximum amount is 255, and then you can specify how much red, how much green, how much blue. Are you still following me, guys, or what's the situation? Felix.
While people are typing, maybe I can ask a question related to the looks that came into the chat earlier. Is there a way to set a standard look or theme for the graphs in base R?
I'm pretty sure you can set it. You can save it such that whenever you upload it, that you can set it. Yeah. I personally don't tend to do this. You know, I just have my, I mean, I'll show it later, just have my, so of course I save my code and just reuse the code, right? So it will always be the same setting. I'm pretty sure you can set your preferences. Yeah, but I would have to look it up. Maybe Felix, maybe you, if you find the time, maybe you can look it up of how to do this. Yeah, so that you don't have to do it each time. Yeah. I mean, what I will usually do, we're still with the high-level commands, and then there's the parameter function, which allows you to change a lot of parameters, and you only have to set them once globally, right? And then whenever you produce a new plot, it will apply these global settings to it. So you don't have to redo it for each single graph, but you kind of have to redo it for each session. Yeah, and we'll come back to this in a minute. I wonder whether I should say something about color a bit more. So let me just quickly stop and go to my slides, people. And look at my slides, because I kind of jumped over the color thing. Colors is really important. That's just on the slide, right? So if you want to know colors, so those are all the R colors that R supports, and actually many more. So one way to choose a color is to look at this chart. Remember the number of the color you like, and then what you could do is you could use the colors function. You kind of say, well, in those colors, give me the first color, the 280th color, and the 60th and 37th color. So basically this says, tell me what this is, tell me what this is. Is that, did I say 80? No, 280. Tell me what this color is, and then tell me what 637 is. 637 here, this one, right? And then it will give you the names. Well, that's white, it's gray 19, and turquoise 2. And then you could use those names and directly type them in, right? Basically, what I would encourage you to do is to make use of colorbrewer.org. So if you don't know this website, this is amazing. This is a website constructed by Cynthia Brewer. She's a cartographer, and she basically came up with color palettes and color schemes that are scientifically tested. Okay, and if you go to the website colorbrewer.org, basically what you can do is you can look for suitable color schemes, right? You can say, well, how many different colors do I need? There are 10 different colors or whatever. What's the color scheme I need? So do I need a gradual scheme? Do I need a diverging scheme? Do I need categorical differences, right? You can even say, hey, make sure it's colorblind safe. We had this issue earlier, right? So you can choose, just give me a colorblind safe option, print a friendly option, and then what this tool will do, it will suggest to you a color palette that you can choose. And then what's really neat, you get a preview of how the colors look. And here you can actually have different encodings of the colors. So you could have the RGB code. That's what I just talked about, right? Where each color is a mix of reds, greens, and blues, right? And then you could literally just look at what colors, what the codes are, and you could copy and paste this into R using the RGB function, right? And in a way, if you wonder how I came up with the dark green, I actually copied this here. So, of course, that's kind of cumbersome. And if you want to be more efficient, what's really cool is that this scheme is also in a package called R Color Brewer. Okay, so you install R Color Brewer, and then if you type display brewer all, it will show you all the color palettes that are available in R. So you don't have to go to the website and copy it by hand. You can have it within R, right? And if you want to use a palette, then what you would do, you would use the function brewer pal, right? You would say, well, how many different colors do I need? And then what's the name of the color palette, right? So if you go boo poo, what's boo poo? Boo poo is here. Where is boo poo? Here it's purple and blues, right? So that's this, it's this palette here, but I just need 5 colors, right? And then you would say, now assign this palette to my colors, and then you do a bar plot or whatever, and then you specify as colors, you just specify my colors, and then this would be the result, right? And you can see this is a very easy way to make your graphs look much more professional in terms of color scheme, right? And to move very quickly from your default settings. Okay, I have questions in the chat. Okay, YouTube is following you well. Okay, Samir has a question. Regarding colors, would you recommend we use colors representative of our variables? If we are measuring political parties or something, do you recommend we use their traditional colors, blues for Dems, red for Republicans in the US, for example? Yes, in this particular case, I do, right? So colors are very powerful because they not only do they pop out, right, pretty attentively, but they also have semantics, which means they have meaning attached to the colors, right? And so your example is a perfect example, right? We know that certain parties have traditionally certain party colors, yeah? And if that's something you can capitalize on, you will basically make it easier for people to read your graphs, yeah? And political parties is a great example where this works. Sometimes you have to be careful because color semantics are culturally context dependent, right? I always say this, but I'm not sure whether it's true. But if you look at red, for instance, like in the Western culture, we associate red with what? With danger, right? With heart, you know, with stop, like, you know, negative images, and green would be good luck, go, you know, save or whatever. And apparently, but I hope we have some Chinese students here. My understanding is that in Chinese culture, red is actually considered a very lucky number, a very positive number, right? So to use color semantics, you have to take care that, you know, you make sure you're moving in the correct cultural context. Okay, on YouTube, we have the question, how would you proceed if you have many different classes, 5 to 100? This seems very difficult to work with colors. Yes, it does. And the true question is, why would you need colors in the first place? Yeah. If you think back to the one example we had with the pop out, so if everything pops out, nothing pops out. So what people would sometimes do is like have different colors for each bar, right? But that's actually not necessary. Why is it not necessary? Because using different colors is intended to distinguish the bars, to say, well, those are different categories, but we already know this. How do we know it? By position in space. Now, we know that each bar corresponds to a group, for instance, a category. So there's actually no reason. The thing that I'm showing here, that's actually not very reasonable to do, yeah, because we could just as well just label down here what the groups are, right? Because if there's a color, then what we would have to provide anyways is a legend, which tells me, well, purple is this group, light blue is this group, etc. Right? And that's not very efficient, because then you have to move between the plot and the legend back and forth. And remember, you know, and think about it. Working memory is limited, so we can probably remember 4 different categories, but with 50 and 100, it's like impossible, right? So I completely advise against using colors in that thing. So is there a way to include labels? Yes, absolutely. Yeah. Let me go back to the R. Okay, so let's stop the slides and go back to, where's my R? Here it is. Yeah. Okay. So I will come back to labels. So bear with me a couple of minutes and I will come back to the label issue. Okay. So for now, that was the important point, right? So let's do the same thing with the line as before, right? So now what we're doing, we're actually explicitly putting the year on the axis, and that's actually something I should say. Some functions you can directly specify the arguments explicitly, right? But sometimes, or in some instances, the functions will use position coding. Yeah, they will know by the position where you put an object what to do with it. And one thing here, one thing is that the x, what goes on the x-axis has the first position, right? And what goes on the y-axis has the second position. Yeah, you don't have to write, like, you don't have to do this, right? The plotting function just knows this already. Okay, so now we have years explicit, right? Previously, we just had the index, but it's much better to have the years. So from 1950 to well into the 2000s, life expectancy on Y. And now we said, let's make a line, right? And what line type? It should be a dashed line, okay? So, and then we can also make the line thicker with using line width, LWD 3. Let's see what happens. Oh, now it's a fat line. Can we have a fat and dashed line? Of course we can. And can we have a fat dashed purple line? Of course we can, right? So again, just for illustration, how you just string arguments into the high-level command, yeah, and it already changes the appearance of your plot. Okay, so now let's add some text and some labels and change the axis. Okay, so as you will see, or as you see, R will put default axis labels here, and it will just use the object name that you plug in, right? But we don't have a title yet. Let me see what am I doing here. So to add a title, we just use the main argument, and then we just type in what we see in the plot. Yeah, usually it's good to use a descriptive title that's actually saying something about what's in the plot and which is not redundant. Yeah. So instead of just saying years or life expectancy over years, well, we know that, right, by looking at the labels. So give it a descriptive title. Let's see what it does. Boom. Life expectancy in Afghanistan is increasing. That's nice. Now let's add an X label and a Y label. Yeah, let's be more explicit here. Let's say that the X lab is year, okay, and then the Y, we say that's life expectancy at birth in years. Okay, so we run this. Oh wow, looks already quite good, I must say. So now what we can do, we can also fiddle with the limits of those axes. Right, as you can see now that the line clearly fills the whole plotting region, right? But we can, we can give it a bit more space, or we can, adjust the axis. And remember, for instance, how we talked about, maybe we don't want the axis to start at 0, right? Maybe we want to play around with this. And the way to do it is to use Y-lim and X-lim, which basically just gives us the limits, the Y-axis, from where to where should it run, right? From where to where should it run? So let's see what this does. So it should run on Y, it should run from 25 to 50, and the years it should run from 1950, which it kind of already does, to 2010, right? So let's run this code. Much nicer. Do you see it now? Looks much nicer here, right? So now we're explicit. Yeah. This also looks much nicer. Just to show you, let's say you would like to have started the Y-axis as 0. You just change the 25 to 0. Okay. There you have it, right? So now it starts at 0. And you see now it's not as, the increase is not as steep, right? It's a bit flatter, right? But as we discussed previously, doing this here, zooming in on the axis, it's not line, right? You're not exaggerating, you're not distorting the line. Yeah. So let me look into the chat. What do we have here? For the ones who would like to install Color Brewer, install packages. Yes, thank you, Bruno. YouTube. So then would it be possible to demonstrate how to add colors to a particular class and add legends? Yeah, we can do that. Yeah. We kind of did in the slides. So let's see. Should we use? Let's use this here. Okay. So we already have the bar chart. We have the legend here with the legend. True. So to be honest, like now to really fiddle around with the legend, I would probably have to look here, yeah, to see all of the, let's look, the possibilities with the legend, right? Yeah, here, legend text, yeah, you can fiddle around with that. What else does it provide? Let me see. Here, it says arguments legend, right? So there's a lots of arguments for the legend. So here, right? Ari's legend, list of additional arguments to pass to legend, right? And then you can click on this. Wow, look, right? Like for the sake of now, I won't go into details here. Just, if you're interested in how to changing the legend, I mean, that's where to find it, okay? But let's add some colors to it. So we had, so let me load the R color brewer package. Okay, and then let's do the, which ones do we do? This one. Okay, so then let's add color. What's it called? Brewer Pal. I need 2 colors, right? And okay. Now let's first see what kind of, oops. So here, let's see what we want to use. Do we have any preference for the color? Let's use, I don't know, let's use a categorical scheme. Let's use accent, okay? Oops. That's the name of this the scheme here. Let's see what it does. Let's oops. There you have it. Oh no, but that's actually, what is it doing? That's actually not good, right? You see that it's actually saying that we can only use 2 colors, or only 3 colors, and then it's randomly cycling through it. That's not something we want. So we need to fix it. Okay, and one way to fix it is to say, okay, then, well, give me 3, right? So if we look at this object, well, if you don't allow me 2 colors, this is in hex code. Okay, it has 3 colors. So what we will do is we will take the first color and the third color. Okay, so we will take this here. Well, it's already here. And then let's say, give me the first color and give me the second or the third. Right. Third parenthesis too much. It doesn't like it. Oh, it needs it. So now much better, right? Yeah, because we need 2 colors, one for the poor, one for the rich, right? And this brewer pal wouldn't allow me to have 2, so I need to access them separately. What happens if we use the second instead? There we go. Okay. So how are we doing on time? Wow, we should move on a bit. Yeah. Okay. Okay, the next thing we want to do to customize your plot a bit is let's change the font. Okay, and let's use the font family Helvetica Light. Let me see whether it's installed in my machine. Do you see this? Yeah. Yeah. Basically, my favorite font would be, or maybe we can do something else. Maybe we want to use Times New Roman. Reason. Do you see this? Yeah. And all of a sudden, once you change your font, I mean, this is really a game changer in terms of customizing the looks, where people will quickly not know anymore, like, how did you produce the plot, right? So my favorite font is actually this one here. And that's what I used throughout. Yeah, I kind of like this one. Yeah. Okay, what else can we do? We can also change the font type, right? So now by default, the title is in bold, but let's say we don't want to have this in bold. Yeah, then we would say font 1, and then font lab would change the fonts on the labels, right? And we give it a 3. Let's see what it does. Do you see what it does? Oh, we should change it back to You see what it does? It looks much better, right? We don't need the fat here, right? So it's now just the regular font. And here it did it in italics. Well, actually, I don't like this in the italics, so just get rid of it, right? Just do this again. It's quite good, yeah? So for now, people see, you know, all I'm doing is I'm still just using one function, right? Just one call, one line of code, basically, right? I'm just using lots of arguments here. And this already looks quite, you know, this already looks quite neat. Let's compare it to the default. Yeah, going from this to this. Yeah, that's quite good. So what else do we have? Clearly, we can also change the sizes of everything, right? We can make the title larger, character expansion.main. We can make the labels larger, character expansion.lab, and also the axis labels here, the tick labels, yeah, which are character expansion.axis. So I want to make this big, this leave it as it is, and make the tick label smaller. Yeah, again, oh, I have to change it to, and I don't like this here, so I get rid of it. There you have it, right? So, okay, now let's move beyond arguments that are provided within the function, and let's set some more parameters. The first thing that I would like to do is I would like to move these things closer to the axis and also move the labels closer to the axis. And in order to do this, I can use the par function, okay? And now how this works is the par function takes lots of arguments and parameter settings. And the important point is, that's what I mentioned previously, this will set the parameters globally. So you set them once, and whenever you call a high-level function afterward, it will apply the same parameters. Yeah, so you don't have to redo it within each high-level command, but it will just stay. And if you want to change it, you have to recall it and change it. And the first thing we're going to change is the marginal graphical parameters. And this takes 3, right? This gives me the distance of the labels, which is the first. Then the distance of the tick labels, sorry, right? And then it will give me the distance of the axis. And the way to understand this is to suppose that outside of the plotting region, there extend lines. So this is line 0, then there's line 1, line 2, line 3, right? So basically there's imaginary lines or coordinates, if you like, and that's where you can put stuff. So let's change this to 2.5 and 0. So now you have to look closely what the change is. So I'm running this, and let me copy this here, because I don't want to reset all the other stuff. Now look what the change is. Did you see it? Now it's moving everything closer. Yeah, it's actually nicer. And now let me do a little trick. Let me change the orientation. Oh, well, now I gave it away. Let me change the orientation of this tick labels by using LAS1. So if I do this, right, also I'm going to copy this version of the plot. And then run it. Do you see this? Yeah, much better, right? So now we're already being picky. So this is a neat little detail. It makes it much easier to read if it's orientated in reading direction. Now I find those tick marks a bit too long. They extend too long. So why I don't just change the TCK argument and make them really small. Okay, so I set this again. I will just copy the same format for you. Yeah, it looks nice, right? So now they're really tiny. Okay, so what else can we do? Now, again, I will just copy this here. And basically also for the rest here. So now what I can do, I can change the background color, right? And now let's do honeydew, background, honeydew. Now if we plot it, do you see this? I mean, I have no clue why you would use this color, right? But you can in principle. You could also say, hey, maybe I should use I don't know, maybe I should use gray as a background. Let's see what it does. Yeah, no, that's not great. Is that better? Or light blue? Well, who knows? Let's stick with the light blue for instance. What you can also do, you can also change the foreground color. Let's see what happens if we change the foreground color to gray. You see what happens? It's basically, it's changing here the plotting, the axis colors, right? So now that I think about it, maybe we should do it in white. Why not? Yeah. And basically, do you see my workflow? It's like, you know, you do something and it's very quickly, you can change it. So it's pretty much trial and error. As long as you're using code, right, you document what you're doing. So, so that's quite convenient, right? So you don't get it right immediately, but you can play around a bit. Yeah. Okay. How does this plot look? Looks already like not as your standard plot. I'm not saying it's going to win a beauty contest, but hey, for just 2 lines of code, it's actually quite impressive. Okay, so those were high-level commands along with the parameter function. Now, what we can do, let's add additional elements to the plot. Okay, let's add some low-level commands to it. So I'm again going to copy this here. Yeah. So I'm running it, but that's the same thing. How about adding a grid? So how can I add a grid? Well, just use, so I have a high-level command which creates this whole plot, and now I can just use the low-level command called grid, right? And it will add to the existing plot. Yeah. And basically, I run it, that's what it will do. Can you see it? It's very light gray here. So maybe we can change the color of the grid. Also to white. Oops. Yeah, now we see it. Also, we can, of course, change the grid, right? So we can make it fat if you would like to. You shouldn't do this. So let's make really sure, right? We want to push it into the background, make it like thin. Oops. Oh, why isn't it doing it? Oh, because, oh, that's a great example. Did you see what I did? So I tried to override it and it didn't change anything. Why didn't it change it? Because the way this works is we already have an existing plot. We're just adding stuff on it, right? Did you just see if I rerun it, it's not changing it. Yeah, it's just adding to the existing plot, right? Just like with a canvas, you cannot undo what you already did. If you do oil painting, you cannot undo the paint, right? Or you can scratch it off, but in principle, you have to paint over it, right? And it's the same principle here. So if you don't like it, so you have to go back and rerun the code. So you would rerun it, okay? So, okay, now it's clean again. Okay, now, right? So now it's the faint ones. We can also fiddle with the line type, right? So 1 is solid, yeah. What would happen if we use 2? Would it give us a dashed? So I'm rerunning the whole thing. Yeah, that's something we would do. I personally don't like the dashed grids because they feel very busy, right? It's kind of, it's also a very nervous look. It's not very calm. You should just do it like in solid lines, rerun it. Okay, so now what we want to do is, and that's actually doing something that we discussed during what was called the spark lines. So now that we know the life expectancy of Afghanistan, maybe we would like to show, well, what's a normal range of life expectancy, right? We see, okay, in Afghanistan, it's going up, but is Afghanistan anywhere near normal in terms of life expectancy? So what we need to do is we would like to have a certain region, right, that we add to the plot. So, and the way to do this is, first of all, we need to define what's normal, right? And here what I do, I just take the quantiles of the life expectancy variable in the whole data set, right? And I just want to have like the 90%, Yeah, so I take the 5% quantile and the 95% quantile. And in between, that's 90% of the cases. Yeah, and I will call this normal life. So let's look at it, right? And then we can look at what it actually is. Yeah, so 90% of all country years in life expectancy fall somewhere between 38 years and 77 years. So that's kind of a normal range. Okay, so now how could we add it? Well, we use a low-level command, which is called rect for rectangle. Okay, so in how to draw a rectangle, we need to put the coordinates of where we want to put it. And basically, to have a rectangle, we only need two coordinates. We need the lower left corner and we need the upper right corner. Okay, so the lower left would be, of course, the x. So we need some x coordinate and a y coordinate. So here I say, well, give me 1940, which would be off the chart. I just want to make sure I'm moving the rectangle well to the axis. So I start with 940, the lower. And where should be the position on y? Well, it should be the first quantile, right? So I just say, well, give me the first number in normal life. And then what's the upper right corner? Again, I'm saying, well, give me the year 2020, which is well off the charts, right? And then in terms of y, just give me the second quantile, the 95% quantile, okay? I can give it a color, and I can say, don't give me a border around the rectangle. I will leave off this for a moment just to show it to you. So now we're going to do this. Do you see what happens? Yeah. Now we have the rectangle just on top of the plot, right? Right, and now the problem is, because we have the canvas model, we painted it on top of it, right? And this is actually related to a question that just came up on YouTube. The grid also seems to be in front of the line, yeah? And that's actually true, right? And why is it? Because we started with the line and then we just added stuff on top of it, right? So, and then the question is, well, what do we do? What do we do? How do we get the line back on, right? And the easier thing is we use another low-level command, which just is called lines, right? Which just has the years on X, the life expectancy on Y. Let's make it wide by 2 and give it a red color. You see, so I'm just over painting. I'm just putting it back on, right? And now, as you can see, not only is the line above the grid lines, is also again above the region, right? Again, yeah, that's the logic. Yeah, is you put stuff on it, then if you want to change it, you either go back and don't do it, or you have to redo it, right? So as we can see here, there's still a border. So what happens if I do what I said, border false? What happens? Yeah, you see then this white border is gone. I think that's a little detail here, but now we need to put the line back on. And clearly what we see now is that, well, starting in the 80s, the life expectancy in Afghanistan moved into a range of what one could consider normal, like 90% of all the other country years. Yeah? But prior to the 1980s, Afghanistan was actually well below the rest of the world. Yeah. Okay, I know somebody asked during the discussion of the spark lines, well, can we put, should we tell what the borders are? Like what's normal, right? And we can do this by adding text to an existing plot, okay? So we use the text low-level function. So what text needs at least is at least 3 things. At least it needs x coordinate, where to put it, and a y coordinate, where to put it, and then the actual text. So let me just do this first. Yeah, so I'm saying it, well, give me a text, put it on 1955, and then on 82. Oh, well, here we are in trouble, right? Because this would be well beyond the chart. So maybe let's start with this here. Yeah, so let's put the lower quantile 1955 and 40. So we want to place a text here, right? So let's see what happens. Yeah, and then it says 5% quantile. It's not great. So what I would like to do is the following. I would like to make it a bit smaller, right? And maybe also change the color, okay? So making it smaller would be here, and then changing the color would be here. Yeah, so but now I have to rerun everything. So because if I just run this here, what will happen? Did anything happen? Actually, I don't see anything happening. Let's just rerun it. Oh, I know why I won't see it, because I think the gray is like, let's not do it in gray then. Let's do it in black. Yes, there you have it, right? So let's make it really small, and then it says, hey, that's the 5% quantile. Let's put the line back on. Okay, now we don't have the upper limit. That's bad. So what we need to do here, maybe we should change it. P80, rerun everything. Right? And then we could say, well, no, that's not great either. Yeah. And as you can see now, I mean, that's not, maybe we can fiddle around with the, maybe we want to move it closer here. So let's not put it on 82, but let's maybe put it on 5. Yeah, better. Do you see it? Now I have to rerun it. And this is, again, that's the workflow, right? You fiddle, rerun it, fiddle, rerun it. So this looks much better, right? Yeah, clearly you see that the life expectancy in Afghanistan, well, it's within the normal range, but really within the low range. So one more argument here with the text is the position, yeah? And in R, positions are ordered like this: 1, 2, 3, 4, right? Bottom is 1, the left is 2, top is 3, to the right is 4. So what happens if I change the position of the label to 4? It will put it on the right of the coordinates. So let's see what happens. Yeah, do you see it? What happens? Or let's put it here. Let's do this here. Now it's moving it here. What if I do it on 3? Oh, it's moving it up here. What if I do it on 2? Oh, it's moving it up here. So yeah, you can basically put the text around your coordinate. Okay, let's just stick with what we had. Okay. Okay. Does this look good? Maybe we would like to have the grid also over the read. Yeah, maybe that's better. But then we have to redo the line. So, and maybe we would also like to have a reference line to see what the average life expectancy is. Okay, so let's calculate the mean of life expectancy, call it average life. Let's run this code. Let's look at average life, what value it is. It's 59 years, right? And then let's add a little line at 59, and we use another low-level command, AB line, a horizontal line. Where should it be? Well, at the average. It should be a dotted line or dashed line. It should be in black. So that's the mean, okay? And we probably should put a label on there so that people know that it's the average, the global average. So I again use text. Global average, okay? So, so I don't know about you people, but this plot is starting to look quite professional, right? And realize what we did, right? We set some parameters, we put on a high-level command, basically just plot, and then we added lots of low-level commands, you know, to add the grid, the rectangle, the text, the lines, redo the line, and that's basically how you produce your graphs. And now what I would like to show you is, well, maybe we should add Iraq as a comparison case, right? So I'm extracting Iraq from the data set. Let's do this. Let's add a line for Iraq. Let's do it in orange. Okay. Let's put some text here to say which one is which. Iraq. Afghanistan. Okay, that's great. So we're directly labeling the lines. And then what we would like to do is we would really like to point the readers or our audience to this thing here. So what happened here? So somewhere in the end of the 80s, there's this decrease in life expectancy. And if you know something about history and the region, then you may have a guess of what's happening here. Let's say we just want to pinpoint it for our audience. So what I will do now, I would like to have a circle around it. So I will use a low-level command called points, which also takes an x-coordinate and a y-coordinate, right? A plotting character, 21 is a circle. I wanted it to be big, right? And black. So that's it. And then I would like to add a text to that, just using the low-level command. What happened here? Yeah. So already looks, I mean, look, the light blue probably is something you wouldn't get away with it, but hey, other than that, it's already a quite professional looking visualization. Any questions? How are we doing on time? How we still have time? Any questions? No? Okay, then what I would suggest is that I'll finish up the basics and then we can spend the rest with just having fun. Okay, should we do it like this? Let's try to come up with a small multiple design, okay? So basically what we want to do is we want to repeat the same plots over and over for different subsets and then arrange them in a neat order, okay? So, and to arrange multiple plots, the first thing that you need to do is to go back to the parameter function, right? And you say, yes.
Before you go on, we now have a question. Can you again explain how you did what happened here in the plot?
Yes, absolutely. Absolutely. So let's just redo everything, right? So I start out with the main plot, the high-level command. Boom. I add the grid, right? I add the rectangle. I put some text on there. I put the line back on. I put the average on, some text. I add the lines for Afghanistan, for Iraq. I put some labels on that, right? And now I want to point to this peak here. Okay, so and actually I kind of rushed over this, but the thing is really, and I did this with trial and error. First of all, you need to catch this point. So how do I catch it, right? Well, you could say maybe I'm just guessing the year. So let's do this differently. Maybe I'm guessing, well, what year would this have been? Maybe 88. So let's put 1988 here. And what's the life expectancy here? Maybe 65. Right? Let's see what I want. Oh, well, that was quite close. So maybe I should do it like this. Hey, that's quite good, right? The way I did it, I just said, well, give me the 8th year and the 8th value in the life expectancy. Yeah, but as you see, you can also like eyeball it and play around until you hit it. So unfortunately, now we have to rerun everything because we have too many. So now this is clean. And now how do we act what happened here? Well, that's text, right? So we need to know where to put the text and what to put here, right? And where should we put it? Well, we should put it near this I want to put it here, right, next to this. So let me just take the same coordinates as I did for the point. And then let's just change the text here. Saddam Hussein is an evil man. Okay. Okay. Yeah. And basically what I did, I then only changed the color. We could also do it in red, right? And we could also change the position. So I put it like right to the coordinate. But we could also put it on top. Now below, sorry. On top would be like this, right? We could put it to the left. We could also make it really large. Evil man, that's a political statement right here. Okay, does that answer the question? So, yes, okay, on YouTube, if I use the family Helvetica Light, for me the code only works if I do not specify the family. Yes, that's correct, right? So you have to make sure that the fonts are installed on your machine, and that R knows how to link and to it and find it. Yeah. Then Christina, what says? Okay, now we have lots of questions. You could also do the maximum in a function, would be a bit more automated. Yeah, the maximum of what? Oh yeah, of course. Like on the Y, Christina, is that what you mean? So on the Y-axis, yeah, instead of typing it in. Oh no, I know what you mean. You to find the, yes, that's a great point. To find the peak here, right? Instead of guessing at 65, of course, what we could have done is to say, give me the max of Iraq life expectancy. So let's rerun it. Make everything clean again. Run it. Okay. But Iraq. And now, yeah, instead of hard coding it or guessing, we could just say, hey, give me the maximum, because this is the maximum here. So let's see what it does. Yeah, bingo. That's great. That's even better, Christina. Yeah. Okay, what else do we have? Let's add this thing here. Okay, what else do we have? Points. Yes, yeah, now I got it. Okay. What is the difference between line and AB line? That's a great point. AB line basically draws a line by specifying the intercept and the slope, okay, A and B. Whereas, therefore, it only allows you to draw a straight line, yeah. Whereas the lines actually just takes X coordinates and Y coordinates, and you can actually do any line, right? You can do wiggly stuff, you can do curves and whatever, right? So that's the difference between the two. Yeah. Is there a package we need for all the font families to work in our code? No, look, this is really cumbersome. And you know, I look this up every year and I forget it every year. I think there's some setting. So basically, there's some setting where you tell R where to find your fonts that are installed on your machine. Yeah, I don't know it on the, out of the top of my head. Is there a way to get rid of the borders on top and the right of our plot? You mean those borders here? Yes, I mean, that's great. Let's definitely do this. So the way I'm doing this is, look at this. I'm first adding another argument. I'm saying axis false. So don't give me any axis. Right? So that's what I get. Let's add the grid. So, and now if I don't like to have any borders here, so I can just add on the axis by hand. Okay, so I could say, well, now that I got the grid, put on an axis on X. This is the first axis on the bottom. Okay, and then let's add an axis to the left, the Y axis. Yeah, as you can see, it's not great. Yeah, so it has this thing here. So what I would do, I would add a box around it, but only make it half of a box, an L. So let's call it box and box type. Boom. Right, and maybe we can even get away with Zipper. Yeah, does that look good? Yeah. Yeah, I actually like it. All of the other commands again. Right. Oh, let's put, okay, now the grid is gone. Let's put the grid after. Okay. Any more questions regarding this? Because then I would really like to show you how to do the small multiple designs. Okay, so let me see. Okay. So the first thing to do is to set up a grid, right, of where to put like the small multiples. And the way to do is to use the par function. And within the par function, there's an argument called mf row. And I think mf could stand for multifaceted, but maybe I'm guessing along rows, okay? And then you specify, well, how many do I need? How many rows? I need 2 rows and 3 columns, okay? So let's see what happens if we do this. First of all, nothing happens. Now it's just setting globally, it's setting up a grid. But now look what happens if we're now calling a plot. Yeah. So it's putting it here. Now if I call another plot, it's putting it here, another plot here, another plot here, here, here. Yeah. So basically it's now dividing up the whole plotting region, right, into a grid of 6 plots, 2 rows, 3 columns, right? So let's say we wanted to do a 3 by 3. Let's rerun it. And then I would say oops. Yeah. Yeah, so you just specify how many you want, and then, and did you see that how it fills it in? So it starts here, and then mf row means it goes row wise, right? So first fills in the upper row, then the next row, and the next row. Okay. You could also do, I mean, it doesn't change much, but you could also use mf col, and it goes column wise. Okay, so we'll run this, and we redo the thing. And we'd first move down. Oops, no. We'd first move down the. No, it actually didn't do it. What am I saying here? That's why I made a mistake here. That's fine. Okay, so let's redo it. Now it's moving down the columns. Yeah. So it doesn't really matter which one you use. Maybe like mf row. So now, of course, the whole point for a small multiple design is that you don't repeat the same graph, but that you repeat it on a different subset of the data. So in our instance, what we would like to do is maybe let's have 6 countries that we want to compare. And the way we do this is the following way. We first look at the country names. And remember, the way the data set is, it's a long data format. So each country has several years. So each country names appears several times. So I would use the unique function to say, well, just give me the unique names of the country, right? So, and then you can see, well, it runs from 1, which would be Afghanistan, to 142, which is Zimbabwe. So those are all the countries. And now what I would like to do from this list of names, just give me a sample of size 6. Just give me 6 names, okay? 6 countries. I just pick them randomly, okay? And then call this object country.sample, okay? So let's look at country.sample. What did we sample? Oh, so we Swaziland, Thailand, Singapore, Togo, Botswana, Venezuela. Okay, that's a great selection. Okay, so and now what we could do in principle, right, is now we could do the same plot that we did for Afghanistan for each of the countries separately, right? But this would be very cumbersome and error prone, right? So instead of having to copy and paste and redo everything for each country, what we will do is we will write everything into a loop, okay? So, and what a loop does, basically a loop, this is this for function here. What the loop does, it specifies a placeholder or index. You just give it a name like I, and then you specify a range for this index, okay? And then what will happen is that this loop will run the functions between the curly brackets, yeah, repeatedly. It will repeat it and repeat it, right? And each time it will set the placeholder or the index to the first value, run the code, right? Then go back up, set the index to the second value, rerun the code, set it to the third, rerun the code over and over again, yeah? Yeah. So basically what we want to do a thing, we want to have 6 plots. So we would like to run this code 6 times, right? From 1 to 6, yeah? And what do we need to change each time? So basically the basic plot is the same as before, right? So let's change the fonts here. Let's not do this. Okay, so very important. Each time we're setting the y lim and the x lim. Well, the x lim should be constant, but the y lim could change, right? But we're fixing this to be between 20 and 80. Yeah? So we make sure that each country uses the same y-axis. Okay, so that's for sure. And then now let's look at where the I comes in. Here is the I. So what does it do? So what we want to do now is we want to plot year over life expectancy over year, but only for a subset of the data, right? And to subset, again, we use the curly bracket. So just give me the year for the subset where the country is equal to country SAM I, right? So the ith country SAM. So that's country SAM, okay? So in the first iteration, I is set to 1. So then we would extract the first country SAM. So we would do this basically. This would be Swaziland. Next round, we would set it to 2. We would extract Thailand. Third iteration, we would set it to 3 to extract Singapore, and so on and on, right? So, and we do the same thing here. We just subset the life expectancy, yeah, only the subset where the country is equal to the country sample, the ith country in the country sample. Okay, and then what we need to do, we also need to change the title accordingly. Yeah, there we just pull out the name from country sample. Does that make sense? Yeah. So okay, let's do it like this. Let's start it, and let's first manually set I to 1. Okay. So this would mean we're now using Swaziland. So if I now type country sample I, this would be Swaziland, right? And now if I just run this code, well, it would give me Swaziland, right? And as you can see, hey, that's actually quite interesting. What happened here, right? You can also add the grid. Don't like the gray. Let's do white. Add the grid. And then average, yeah? Okay. So now we have it once, and now basically what we're doing is let's set I to 2, okay, and rerun the code. And we would do the same for Thailand, yeah? So now we don't have to do this by hand, we just let it run in the loop. Yeah? So I'm rerunning this here, resetting it, and then from 1 to 6. Yeah, and now we have a neat small multiple beside. Okay, so What's missing? Well, we said, hey, we should order it in a sensible way, right? So what would be a sensible way? There's different ways. I mean, we could order it by pattern, for instance, like both Swaziland and Botswana really have this. So they improved, and then they really, had really a worse situation, whereas the other countries really have a stable increase in life expectancy. So that would be one way. Another easy way would be to just sort it by the average, within country average. Okay, so the way we're doing this is we're first setting up an empty container called means. So I want to calculate what's the mean life expectancy in Swaziland over the years, what was the mean life expectancy in Thailand over the years, in Singapore, etc. So I'm first producing an empty container. And I'm saying repeat NA. NA means missing value 6 times. Okay, so let's look at means. Oops. Oh. It says NA, 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 NA. Yeah. So now what I'm doing, I want to fill in those means with the country-specific means. Okay, so the way to do this, again, I write a loop, I in 1 to 6. So I repeat what I'm doing here 6 times, right? And all I'm doing is I am taking the mean of the life expectancy in the country, which is the first in the country sample, the second in the country sample, and so on and so on. And then I write this to the first position, the second position, the third position. So basically fill in this container here, okay? So let's do it. Now let's look at means. Well, and now we see the means vary widely, as we can see here, right? Swaziland really has the lowest mean, Singapore the highest, right? So, and now what I would like to do, I would like to order the plots according to the mean. So we use a command that we already know, which is order, okay? So basically tell me in which order the means are, and I want them to be in a decreasing order. And I will specify an object called ord. So let's do this. Let's first just run the order and see it. Yeah. So in decreasing order, this one is the smallest, so it should go last. That's correct. The third one is large, so it should go first, right? The 6th is the second largest, so it should go second. Yeah. So that makes sense. Let's specify ord. Let's look at ord. That's just giving us this the sequence here. And now I redo what I just did. But instead of saying go from 1 to 6, yeah, and remember the way it was filled in, right? So we started with the first and then filled in the rows. Now let's change the order of the plots. Let's just go by ord, okay? Let me change the as well. Now if I go from 1 to here. Yeah, do you see it? Yeah, now it's ordered. Now Singapore goes first, then Venezuela, Thailand, Botswana, Togo, Swaziland. Yeah. And it just makes basically what it sorts the high life expectancy with a slow increase from the group where there's actually a decrease, right? So pattern stands out better. Yeah. Finally, let's look at the time. Oh, we still have some minutes left. I just want to again show you that this small multiple design, basically all it took was, well, actually you can erase this here. All it took was this line of code, this line of code, this line, this, yeah, just this bit here. It's not too much, right? But this was able to actually produce a very professional looking small multiple design. Yeah. And I hope that this proves to you or shows you the potential of visualizing data in R. Okay, do we have questions? Stop here. Are you still with me? You're so quiet. It's very quiet. So, okay, Robin asks, could you please repeat which earlier function you had to call again to be able to run the graph again? Robin, can you be a bit more, after you use the loop, if you go back, take a look. After I use the loop, so here I use the loop. So I'm a bit out of, so basically all I did is just rerun the complete code, right? So to redo it, just rerun the complete code from top to bottom. Yeah, just. Oh, now that's actually cool because now I include the country sample in here, so it's sampling each time, 6 countries. That's actually neat. So let's do this. Let's get 9 countries, right? And then okay, that's not so great. Why doesn't? Oh, because it's from 1 to 6. Yeah, I don't. Well, and now I need to 9, of course. Yeah, and then, I mean, what we could do is let's make the margins a bit smaller. Let's say 2, 2, 1, 1. It still show up. Yeah, well, okay, it's not great, but let's go crazy. Let's try this. 5, 20, 20. Yeah. Yeah. Okay, so more questions in the chat. Okay, a lot of thanks from YouTube. You're very welcome, YouTube. Can we set, oh, so there's a great question from YouTube. Can we set the order arbitrarily? Yeah, we can, absolutely. Yeah, so we can, instead of ordering it, we could just say, hey, why don't you do the order 20, 19, 17, 6, 5, 4, you know, whatever, 49 doesn't exist, right? And then just use this order. You can, yeah. So if you want to eyeball it, but that's kind of related to what Christina said previously. I mean, if you just eyeball it and say, hey, I want to order this here, it's probably more efficient to actually have a rule that you can code, like the maximum. And it's better to just have like a rule to say, hey, calculate the means and give me the order by the means, right? So I think it was DevOps to clean the graph history, or can you just manually press on the little broom of the graph? You can start over again. So if you do this, oops, doesn't allow me to do it. I'm stuck, doesn't allow me to do it. For some reason, I can't go back to, okay, sorry, I'm stuck. How would the code be if we wanted, so how would the code be if we wanted to have a graph for all the countries in data set, not just for a subset? Okay. Okay, no, maybe I need to stop and no, okay, you know what, guys? There's some, I didn't see this because your images were basically, no, I don't want to do this. Okay, so you want to have the whole, oh yeah, okay. So let's do it like this. So you want to have a graph with all the countries, right? So what I would do is the following. I would use the same basic building block. And then what I would do, I would first of all start with the first country. I would say, give me the unique country. Okay, the first one. So this would be Afghanistan again. Let's see what this does. So start out with 1. So, oh, why is this? Oh, this is wrong. This should be changed to 1 as well. So now, of course, we don't want to do it in a grid, but we want to have a combined graph for everything. So we have to change MF row back. So it was globally set. So, and as long as we don't reset it, it will stay. So we want just 1 row and 1 column. Okay. So boom. Then, of course, since we want to do many countries, we probably wouldn't call it Afghanistan, but we'll give it a different title. Let's call it The World is Getting Better. Okay, to end on a happy note here, right? So, right, and now what we want to do, now we need a line for each country, right? How would we do this? Well, we would add a line, right? So let's use we already had the lines command up here, right? So let's steal it here, bring it down here. So and all we need to do now is to subset it, okay? So we want a line for each country. So let's take this here, the subset trick. Okay, we don't want the first country because we already plotted it. Just give it an empty placeholder I, and now all we need to do is write a for loop from I in 2. Let's not start with 1. We already have 1 to 142. That's how many countries there are. Put it in a loop. So and now let's rerun everything. And as you can see, it's not doing what I want to do. Can you spot the mistake? That's the problem with copy and pasting. This should be data. That's the problem with copy and pasting. So let's redo it. Boom, there you have it. So now you have a country line. And what you immediately see, indeed, the world is getting better, right? There's increase, but there's some outliers here that really have a dip. Do we have the red lines? Maybe not. So maybe we can pretty up this a bit. Oh, I know what to do. Let's make it fancy. Let's have the background in black. Oh, this looks good. Let's not make the lines so thick, maybe. Let's make them. And then let's change them to transparency. I'm changing the RGB code, right? Just red, nothing else. Maximum value is 250. And then let's set the maybe we can just get away with. Yeah, let's try whether this works. Oh, it didn't work. It did not work. So we need to put in. Oh, look at that. That looks cool, right? So maybe we would like to change the line width to, how do we change it? To 1, and let's also change the color. Oh, here it's already here. Also change the color. So what I'm doing here is basically using transparency on the lines, yeah? And you basically say, well, what's the color in RGB code? What's the maximum? 2.5? But don't give me the full color, make it a bit transparent. So I'm putting a value lower to 255 here. Let's put this here. That's something I don't need anymore. And now you basically also see the workflow, right? It's really trying out stuff, changing it, rerunning it. Yeah, this looks quite cool. Maybe we should call axis right. Yes. Maybe we should change again the margins to 4422. Yes, and we should also change the color of the labels, maybe. Like this here. So we can top. So we see the title. Oh, okay. The color of the title needs to be white as well. So let's call main white. Okay. So, okay, that's just playing around, people. Yeah. But as you can see, I mean, this is, so if you go to the internet and look for data viz, you will see all those fancy visualizations. Like the big trick that they're all using is use a dark background, like black, and then use transparency. And all of a sudden it will look like techie and stuff. But as you can see, it's I mean, you know, it's no magic. Yeah, it's very easy to do. So, Olga, is that, or the YouTube question? Yeah, that's the graph for all the countries. Okay, hey, but you know what we could do now? We could still highlight one country, right? So let's could still do this here. Yeah, now that we have all the countries, we could still add Iraq to see how Iraq is doing. Yeah. Oh. Maybe we should say that it's Iraq, so I'm again stealing just this piece here, putting it down here and running it. That's Iraq. Okay. Okay. So look at the time. Let me see what else we have. By order, I would automatically know that's an order function. So no, order is just the object. Order is the function, right? The order function is order, and then you can just call the object whatever you want. Yes, that's what Felix basically said. People, I think we've come to the end. We haven't actually touched on lots of other fun stuff. Basically, this is really just the tip, you know, of the iceberg. There's so much more to do. But I hope that, you know, you got a sense of what's possible with R in data viz. I hope you got some notions of how to, you know, make decisions based on principles. And as I said before, the slides are there for you. You already have access to them. The code is there for you. And then whatever we haven't touched, you know, you have the code. And I wish you lots of fun with it. Yeah. And I think we should stop here. Okay. Olga, do you want to say some final words, or does everybody just go home?
Thanks a lot. Yeah, we actually have a closing video. So, but thanks so much for giving this workshop and serving as an instructor today. And thanks everyone to participating and paying attention, being active in the chat with questions.
Yeah, thank you. Take care. Bye-bye.